Hello there, and welcome. Tonight I want to take you somewhere extraordinary, somewhere that exists not in the physical realm of telescopes and spacecraft, but in the quiet corners of imagination where the rules of reality become soft and malleable, like clay in the hands of a dreamer. You're lying there right now, perhaps in your bed, perhaps on a couch, maybe even sitting in a comfortable chair with the weight of the day slowly dissolving from your shoulders, and I want you to know that you found exactly the right place to be. The journey we're about to take together doesn't require you to move a single muscle, doesn't ask you to do anything except breathe slowly and let your mind drift along with my voice as we explore one of the most fascinating questions that has ever whispered itself into existence. What if gravity, that invisible force that holds you so gently against your mattress right now, that keeps your blanket draped over you, that ensures your pillow stays beneath your head, what if it worked completely differently? What if, instead of pulling everything together in its quiet, persistent embrace, gravity pushed everything apart with the same gentle, unwavering consistency? I know it sounds impossible at first, perhaps even absurd, and that's perfectly fine because the best journeys into understanding often begin with a question that makes us pause and wonder if we've heard it correctly. You see, we're so accustomed to gravity's downward pull that we rarely stop to consider how fundamentally it shapes every single moment of our existence, from the way water flows down a stream to the way planets orbit their stars in the vast darkness of space. But tonight, in the safety and comfort of wherever you're listening from, we're going to very gently, very slowly, turn the universe inside out in our minds and imagine what existence might feel like if the most fundamental force we know worked in reverse. And before we drift any deeper into this cosmic thought experiment, I'd love to know where you're joining me from tonight. What corner of our pulling gravity world are you resting in right now? Is it late evening where you are, with stars perhaps beginning to peek through your window? Or are you listening in the quiet hours before dawn, when the world feels most still and receptive to impossible ideas? Feel free to share in the comments below where you're tuning in from and what time it is in your particular spot on our spinning Earth, because there's something beautiful about knowing that people all around our planet, held down by the same gravity, are simultaneously imagining it working in reverse. And if this journey into cosmic possibility resonates with you, if you find yourself curious about more of these gentle explorations into the unknown, a soft tap on the like button and a quiet subscribe would mean we can continue these nighttime wanderings together through many more mysteries of the universe. You know, gravity is perhaps the most intimate force you'll ever encounter, though you might never think of it that way. Right now, as you lie there or sit there, every atom in your body is having a conversation with every atom in the earth beneath you, and that conversation is gravity. It's a whisper that never stops, a gentle insistence that says, stay close, stay near, don't drift away into the cold darkness of space. It's been with you since before you were born, this constant companion that has shaped the very structure of your bones, the strength of your muscles, the way your heart has learned to pump blood up to your brain despite its downward pull. When you were a child learning to walk, every stumble and every successful step was a negotiation with gravity, a dance between your will to move and its will to bring you back down to earth. And now, after all these years, you've become so perfectly adapted to living in gravity's embrace that you rarely notice it at all, like a fish that doesn't know it's swimming in water until someone asks it to imagine the absence of the sea. But what would happen to that intimacy if gravity suddenly changed its nature? Not violently or catastrophically, but simply reversed its intention, transforming from a force of attraction into one of repulsion. Imagine for a moment that every particle in the universe, instead of reaching out with invisible hands to pull other particles closer, instead pushed them away with the same steady, patient force. The earth beneath you would still be there, but instead of holding you down, it would be gently, perpetually trying to nudge you upward, away from its surface. The air molecules around you, rather than being held in a blanket around our planet, would be slowly, constantly trying to escape into space, held in place only by, well, what would hold them in place? This is where our imagination must become creative, must find new forms of balance and stability in a universe that prefers separation to unity. Perhaps in this pushing universe, we would need to reimagine everything about how we live and move through space. Your bed, instead of being a surface you sink into, would become something you would need to be gently tethered to with soft restraints that keep you from floating away during the night. Buildings wouldn't rise from foundations dug deep into the ground, but would need to be anchored with a different kind of architecture, one that acknowledges the Earth's desire to push them skyward. Trees wouldn't grow up from roots that grip the soil, but might need to develop entirely different strategies for staying connected to the planet that constantly tries to repel them. It's a world that seems impossible at first, but as we explore it together tonight, slowly and thoughtfully, we might discover that impossibility is just unfamiliarity wearing a frightening mask. The interesting thing about imagining gravity in reverse is that it forces us to recognize how much we take for granted about the way things fall, settle, and come together. When you pour water into a glass, you don't think about the remarkable fact that the water chooses to flow downward, gathering in the vessel rather than dispersing in all directions. When you see clouds in the sky, you don't usually contemplate the delicate balance between gravity pulling water droplets down and air pressure keeping them aloft. But in our pushing universe, none of these everyday miracles would work the same way. Water wouldn't flow downward because down would no longer be the direction of gravitational attraction. It might instead need to be contained in sealed vessels, or perhaps it would behave more like a gas, expanding to fill whatever space it's given, always trying to spread out rather than come together. And yet, as alien as this pushing universe might seem, there's something in our actual cosmos that behaves remarkably like what we're imagining. Scientists have discovered that the universe itself is expanding, and not just expanding but accelerating in its expansion, as if something is pushing galaxies apart with ever-increasing enthusiasm. They call this mysterious something dark energy, and it accounts for roughly 68% of everything that exists. Though we understand almost nothing about what it actually is or how it works, it's as if the universe we live in is actually a hybrid of our normal pulling gravity and this strange pushing force, with gravity dominating at small scales like planets and solar systems, while dark energy rules at the vast scales of galactic clusters and beyond. So perhaps our thought experiment tonight isn't as purely fictional as it might first appear. Perhaps we're simply imagining what the universe would be like if dark energy's pushing force extended all the way down to the smallest scales, affecting not just galaxies but planets, people, and particles. Think about your own body for a moment in this pushing universe. Every cell, every molecule, every atom would be experiencing a constant outward pressure, trying to separate from its neighbours. The complex structures that make up your organs, your bones, your brain, would need some other force to hold them together, something stronger than the repulsive gravity that tries to tear everything apart. Perhaps electromagnetic forces would become dominant, or perhaps life would evolve entirely different mechanisms for maintaining cohesion in a universe that fundamentally prefers dispersal. Your blood wouldn't naturally flow downward through your veins, but would need to be actively pumped in all directions, fighting against the tendency of every blood cell to drift away from every other blood cell. Breathing would be different too, as air wouldn't naturally settle in your lungs, but would try to expand outward, requiring a different kind of respiratory system to capture and process oxygen. It's a question that might seem purely academic, this reversal of gravity, but there's something deeply meditative about reconstructing the universe from the ground up, or perhaps I should say from the sky down, since in our pushing cosmos the ground would always be trying to become the sky. When we imagine such fundamental changes to reality, we're forced to examine our assumptions about what is necessary and what is merely familiar. We begin to see that the universe we inhabit, with its particular blend of forces and constants, is just one possible configuration among potentially infinite alternatives, and in that recognition, there's both humility and wonder, a sense that existence itself is more flexible and mysterious than our everyday experience suggests. You might be wondering how planets would even form in such a universe, and that's a beautiful question to hold gently in your mind as you drift deeper into relaxation. In our pulling gravity cosmos, planets begin as tiny specks of dust and gas that attract more dust and gas, growing larger and larger over millions of years until they become the massive spheres we see today. But if gravity pushed instead of pulled, those initial specks would never come together. They would drift apart like seeds on the wind, never accumulating into anything larger. Unless, of course, there were other forces at play, other mechanisms we haven't imagined yet that could create islands of stability in an ocean of repulsion. Perhaps magnetic fields could create zones where matter could gather despite gravitational repulsion, or perhaps the very nature of space itself would be different, with pockets and folds where the pushing force weakens enough for other attractions to take hold. The moon outside your window tonight, if you can see it, or even if you can just picture it in your mind, exists because gravity pulled together debris from a massive collision billions of years ago. In our pushing universe, that debris would have simply dispersed into space, never forming the gentle companion that has watched over Earth's nights for so long. There would be no tides, since tides are caused by the moon's gravitational pull on our oceans. Without a moon, and without pulling gravity, the oceans themselves would be entirely different, perhaps existing as vast spheres of water held together by surface tension alone, floating above a repulsive Earth like enormous drops of dew that never quite touch the petals they hover above. And speaking of the Earth itself, our planet is a sphere because gravity pulls equally in all directions, causing matter to collapse into the most efficient shape possible. But in a pushing universe, would planets be spheres at all? Perhaps they would be more diffuse, cloud-like structures, held together by forces we can barely imagine, or perhaps they wouldn't exist at all in any form we would recognize. The very concept of a planet might be meaningless in a cosmos where matter prefers to spread out rather than clump together. Instead of discrete worlds orbiting stars, we might have vast, thin veils of matter spread across enormous distances, never quite touching, never quite separating completely, existing in a perpetual state of almost connection that defines an entirely different kind of existence. This brings us to an even deeper question about the nature of space itself. In our universe, massive objects like stars and planets curve space-time, creating what we experience as gravitational attraction. Einstein showed us that what we feel as gravity is actually the curvature of the fabric of reality itself, with objects following the straightest possible paths through curved space. But if gravity pushed instead of pulled, would space curve in the opposite direction? Would massive objects create hills in space-time rather than valleys, causing everything to roll away from them rather than toward them? The mathematics of such a universe would be beautifully inverted, with equations that mirror our own but with crucial signs reversed, plus becoming minus, attraction becoming repulsion, gathering becoming scattering. And yet, even as we imagine this pushing universe, there's something in us that recognizes the deep necessity of coming together, of connection, of the pull that brings separate things into relationship. Perhaps this is why gravity as we know it feels so fundamental, so right, so aligned with our deepest instincts as conscious beings who seek connection with others. We are creatures of gravity not just physically, but emotionally and spiritually, always feeling the pull toward other people, toward meaning, toward understanding. In a pushing universe, would conscious beings evolve to value separation over connection? Would they find beauty in the ever-increasing distances between things, in the slow drift apart that would define their reality? Or would they, like us imagining their world, dream of a universe where things come together, where bonds form and strengthen, where the fundamental force of existence brings things into unity rather than driving them apart? As you lie there tonight, feeling the gentle, constant pull of Earth's gravity holding you in place, you might begin to appreciate this force in a new way. It's not just keeping you from floating off into space, it's actively creating the possibility of your existence. Every breath you take is possible because gravity holds our atmosphere in place. Every sip of water you drink flows down your throat because gravity defines what down means. Every step you take is a small triumph over gravity's pull, and every moment of rest is a surrender to its embrace. We live our entire lives in negotiation with this force, usually without even realizing it, like dancers who have forgotten their dancing because the music has been playing since before they were born. In our imaginary pushing universe, music itself would be different. Sound waves travel through air, because air, molecules are held together closely enough to transmit vibrations, but if gravity pushed those molecules apart, would sound exist at all? Perhaps beings in such a universe would communicate through electromagnetic radiation instead, or through quantum entanglement, or through means we can't even conceive of with our pulling gravity minds. Their art, their science, their entire culture would be built on fundamentally different foundations, quite literally, since foundations as we know them wouldn't exist in a world where the ground pushes up instead of pulling down. Consider for a moment the simple act of rain falling, or rather, in our pushing universe, rain rising. Water droplets would form in the lower atmosphere and be pushed upward, away from the Earth, creating reverse waterfalls that flow towards space instead of toward the ground. Rivers would run uphill, always seeking to escape the planet that repels them. The water cycle as we know it would be impossible, and life, if it existed at all, would need to find entirely different ways to distribute and recycle this essential molecule. Perhaps plants would evolve to capture water as it tries to escape upward, with root systems that extend into the sky rather than into the soil, creating forests of inverted trees that look like underwater coral reefs standing on their heads. The beauty of this thought experiment is not in its practical application. We're not trying to actually reverse gravity or discover some hidden truth about how the universe secretly works. Instead, we're using imagination as a tool for appreciation, a way to recognize the profound importance of something we usually ignore. By imagining gravity reversed, we see more clearly how essential its current direction is to everything we know and love. It's like imagining a world without color to better appreciate the sunset, or contemplating silence to better hear the music that surrounds us. Sometimes we need to imagine the absence or reversal of something to truly understand its presence and value in our lives. As we continue deeper into this exploration tonight, I want you to remember that you're safe and grounded, held securely by the same gravity that has held your ancestors for millions of years. This journey into an inverted universe is just a gentle mental adventure, a way of stretching our understanding while remaining perfectly comfortable where you are. There's no need to grip or tense against the imaginary push we're contemplating. Instead, let yourself relax even more deeply into gravity's actual pull, feeling how it supports you, cradles you, keeps you connected to this beautiful planet we call home. The thought experiment we're conducting is like a dream within a dream, a story we're telling ourselves about how things might be different, which only makes us more aware of how things actually are. You know, scientists have been studying gravity for centuries, from Galileo dropping objects from the Tower of Pisa, to Einstein reimagining space and time as a unified, flexible fabric. And yet, for all our mathematical models and experimental confirmations, gravity remains deeply mysterious. We can describe what it does with incredible precision, but we still don't fully understand what it is. Is it truly a fundamental force, or is it an emergent property of something deeper? Why is it so much weaker than the other fundamental forces, and why does it only attract, never repel, at least at the scales we can directly observe? These questions keep physicists up at night, though tonight we're using them to help you drift off to sleep, wrapped in the beautiful mystery of a universe that still has secrets to share. In quantum mechanics, there's a concept called the uncertainty principle, which tells us that we can never know everything about a particle simultaneously. The more precisely we know its position, the less precisely we can know its momentum and vice versa. Perhaps there's a similar principle at work with gravity. The more we understand its effects, the more mysterious its ultimate nature becomes. And perhaps that's perfectly fine, even beautiful. A universe without mystery would be a universe without wonder, and wonder is what makes consciousness worthwhile. As you imagine gravity pushing instead of pulling, you're participating in that wonder, adding your own imagination to humanity's long conversation with the cosmos about what is, what might be, and what it all means. The room around you right now, whether it's dark or dimly lit, whether it's familiar or somewhere new, is held together by forces that work in perfect harmony. The walls stand because gravity pulls them down onto foundations that push back with equal force. The air you breathe maintains just the right pressure because gravity compresses our atmosphere against the Earth's surface. The temperature stays relatively stable because gravity keeps our planet close enough to the sun to receive its warmth, but not so close that we burn. Every comfortable thing about your current environment depends on gravity working exactly as it does, pulling with just the right strength in just the right direction. In our pushing universe, comfort itself would need to be redefined, rebuilt from first principles that acknowledge repulsion rather than attraction as the fundamental organizing force of reality. But perhaps there's something appealing about a pushing universe too, something liberating about the idea that the fundamental force of existence encourages things to spread out, to explore, to seek their own space rather than clustering together. In our pulling universe, we sometimes feel the weight of gravity as a burden, especially as we age and our bodies find it harder to resist its constant downward tug. But in a pushing universe, would we feel constantly lifted, perpetually encouraged to rise, to expand, to become more than we were? Or would we feel untethered, disconnected, alone in a cosmos that actively encourages isolation? These are the kinds of philosophical questions that emerge when we really sit with our thought experiment, when we follow it beyond the merely physical into the realm of meaning and experience. Right now, as you continue to relax and listen, gravity is doing thousands of things for you that you're not consciously aware of. It's helping your blood pool in the right places when you lie down, triggering pressure sensors that tell your body how to adjust your circulation for rest. It's creating the conditions for convection currents in the air around you, ensuring that heat and fresh oxygen circulate even in still rooms. It's maintaining the pressure that keeps the water in your cells from boiling away into vapor. Every biological process in your body evolved in the presence of gravity, and depends on it in ways we're only beginning to understand. Astronauts who spend extended time in microgravity experience bone loss, muscle atrophy, and cardiovascular changes that show us just how deeply gravity is written into our biological instruction manual. In our pushing universe, life would need a completely different instruction manual, one written in a language of repulsion rather than attraction. DNA itself might not exist, since it depends on molecular attractions to maintain its double helix structure. Proteins wouldn't fold into their functional shapes without the attractive forces that currently guide them. The very chemistry of life as we know it assumes that atoms and molecules want to come together, to form bonds, to create increasingly complex structures. In a purely repulsive universe, complexity itself might be impossible, or it might take forms so alien to our current understanding that we wouldn't recognize it as life at all. Perhaps beings in such a universe would be made of stable patterns in fields rather than arrangements of matter, or perhaps they would exist as dynamic processes rather than physical entities, constantly recreating themselves against the tendency of everything to fly apart. This is the deep end of our thought experiment, where physics meets philosophy meets poetry, where the rigorous meets the speculative meets the imaginative, and it's exactly where we want to be tonight, in that liminal space between waking and sleeping where impossible things feel almost possible, where the rules of reality become soft and negotiable. You don't need to hold on to all these ideas or try to make perfect sense of them. Let them wash over you like waves on a beach, each one bringing something new and carrying something away, creating a rhythm of thought that's more about feeling than understanding. The purpose of imagining gravity in reverse isn't to solve some cosmic puzzle, but to experience the gentle vertigo of seeing familiar things from a completely unfamiliar angle. And so we return now from our imaginary pushing cosmos to the real universe you inhabit, the one where gravity pulls rather than pushes, where things come together rather than fly apart, where you can rest securely on your bed without fear of drifting away into the night sky. It's important to ground ourselves in reality before we venture further into speculation, to understand what gravity actually does in our universe before we continue exploring what it might do if it worked differently. You see, the gravity you're experiencing right now, the gentle force that's holding you down as you listen to my voice, is both incredibly simple and mysteriously complex, both perfectly ordinary and deeply strange. It's been with us so long that we rarely think about it, yet when we do turn our attention to it, we find layers upon layers of beauty and mystery that scientists are still working to unravel. Let's start with what you're feeling right now, that sensation of weight, of being pressed gently but firmly against whatever surface you're resting on. That's gravity manifesting at the human scale. Every atom in your body is being pulled toward every atom in the Earth, and while each individual pull is impossibly weak, the combined effect of all those countless tiny attractions adds up to the force we call your weight. But weight isn't really a property of your body alone. It's a relationship between you and the Earth, a conversation between masses that never stops. If you were on the moon right now, you would weigh about 1/6 of what you weigh on Earth, not because you would have less mass, but because the moon has less mass to pull on you with. And if you were floating in deep space, far from any massive objects, you would be weightless, though your mass would remain unchanged, waiting for another massive object to come close enough to resume the gravitational conversation. This distinction between mass and weight is one of those insights that seems simple once you understand it, but represents a profound shift in how we think about reality. For most of human history, people assumed that weight was an intrinsic property of objects, that heavy things were heavy because heaviness was built into them somehow. But Newton's great insight was that weight is actually about relationship, about the mutual attraction between objects with mass. The Earth pulls on you, yes, but you also pull on the Earth with exactly the same force. It's just that the Earth is so much more massive than you that your pull doesn't affect it noticeably, like an ant pulling on an elephant's leg. But the mutuality is there, the reciprocity that makes gravity not a one-way force but a genuine interaction between everything that has mass in the universe. When you drop something, perhaps a book or a pen, and watch it fall to the ground, you're witnessing gravity in its purest form. But what you're seeing isn't just an object being pulled down, you're seeing the curvature of space-time itself being revealed. Einstein taught us that massive objects don't really pull on each other through empty space. Instead, they curve the fabric of space-time around them, and objects follow the straightest possible paths through that curved fabric. Imagine space-time as a stretched rubber sheet, and the Earth as a heavy bowling ball placed on that sheet. The bowling ball creates a depression, a valley in the sheet, and if you roll a marble near that valley, it will curve toward the bowling ball, not because the bowling ball is pulling on it with invisible strings, but because the marble is following the curvature of the sheet itself. This is what's happening to you right now. You're not really being pulled toward the Earth, you're following the curvature of space-time that the Earth's mass creates. If you could somehow see space-time directly, you would see yourself sitting at the bottom of a gentle valley, a depression in the fabric of reality created by our planet's presence. And the Earth itself sits in a larger valley created by the Sun, which is why Earth orbits our star rather than flying off into interstellar space. And our entire solar system sits in the subtle depression created by the Milky Way galaxy, and so on, creating a nested hierarchy of gravitational influences that extends all the way to the edge of the observable universe. But let's bring our attention back to Earth, to the gravity you know most intimately. Have you ever wondered why our planet is round? It's not a coincidence or an accident. It's gravity's signature, its way of organizing matter when enough of it comes together. Any object with enough mass will eventually become spherical because gravity pulls equally in all directions toward the center of mass. Mountains can only grow so tall before gravity pulls them down. Valleys can only sink so deep before the pressure of overlying rock causes the bottom to flow and rise. Over millions of years, gravity smooths out irregularities, creating the near-perfect sphere we call home. The Earth isn't perfectly spherical, of course. It bulges slightly at the equator due to its rotation, but gravity is always working to make it as round as possible, like a cosmic sculptor with infinite patience. This patient, persistent quality of gravity is perhaps its most remarkable characteristic. Unlike electromagnetic forces, which can be shielded or blocked, gravity penetrates everything. There's no material that can block gravity, no way to insulate yourself from its effects. It passes through the thickest walls, the densest metals, even through the Earth itself. Right now, you're being pulled not just by the ground beneath you, but by every part of the Earth, including the parts on the opposite side of the planet. The gravity from Earth's core reaches up through thousands of miles of rock and metal to tug gently on you, and there's nothing that can interrupt that connection. It's the ultimate force of connection, linking every piece of matter to every other piece across any distance, through any obstacle. Scientists have measured gravity with incredible precision, and what they've found is both reassuring and mysterious. The gravitational constant, usually written as g, is one of the fundamental constants of nature, a number that appears to be the same everywhere in the universe and throughout all of time. When astronomers observe distant galaxies billions of light years away, they see gravity working exactly as it does here on Earth, following the same rules, obeying the same equations. This universality of gravity is part of what makes science possible. We can understand the cosmos because the same physical laws that govern falling apples also govern orbiting planets, colliding galaxies, and the expansion of space itself. But here's where things get interesting and a little strange. Gravity is by far the weakest of the four fundamental forces. The electromagnetic force is about 1036 times stronger than gravity. That's a trillion times stronger. The strong nuclear force that holds atomic nuclei together is even more powerful at short distances. You can see this weakness yourself with a simple experiment. A small refrigerator magnet can hold a paperclip against Earth's gravity, even though the magnet is tiny and the Earth is enormous. The entire gravitational pull of our planet can be overcome by a magnet you can hold in your hand. This weakness of gravity is actually crucial for the existence of the universe as we know it. If gravity were much stronger, stars would burn too quickly and die before life could evolve. If it were much weaker, stars might never form at all, leaving the universe dark and cold. Yet despite its weakness, gravity dominates the large-scale structure of the universe because it has two special properties that the other forces lack. First, it has infinite range. Gravity's influence extends forever, getting weaker with distance but never completely disappearing. Second, it's always attractive, at least in our normal experience, which means its effects add up rather than cancelling out. Electric charges come in positive and negative varieties that neutralize each other, but mass only comes in one variety, and it all attracts all other mass. So while gravity might be weak, given enough mass and enough time, it becomes the architect of everything from solar systems to galaxy clusters to the cosmic web itself. Speaking of the cosmic web, one of the most beautiful discoveries in modern astronomy is that the universe has a structure that looks remarkably like a three-dimensional spiderweb or neural network. Galaxies aren't distributed randomly through space. They're arranged along filaments and sheets, with vast voids between them. This cosmic web was woven by gravity over billions of years, starting from tiny variations in density in the early universe. Where matter was slightly denser, gravity was slightly stronger, pulling in more matter, which increased the gravity further, creating a runaway process that eventually formed the galaxies and galaxy clusters we see today. It's like watching rain on a window. Tiny droplets merge into larger drops, which merge into streams, all following the invisible paths laid down by the interplay of gravity and surface tension. The Apollo missions gave us some of the most visceral demonstrations of how gravity works beyond Earth. When astronauts walked on the moon, they discovered they could jump much higher and farther than on Earth, not because they were stronger, but because the moon's weaker gravity, about 1/6 of Earth's, couldn't pull them down as quickly. They had to learn new ways of moving, developing a distinctive bouncing gait that was more efficient than normal walking in the low-gravity environment. And when they dropped objects like the famous hammer and feather that Apollo 15 astronaut David Scott released simultaneously, they fell at exactly the same rate, proving Galileo's centuries-old assertion that gravity accelerates all objects equally, regardless of their mass or composition. The International Space Station, orbiting about 250 miles above Earth's surface, provides us with a continuous natural laboratory for studying gravity, or more precisely, the effects of microgravity. The astronauts aboard the ISS aren't beyond Earth's gravity. In fact, they're experiencing about 90% of the gravitational force you feel right now. The difference is that they're in constant freefall, orbiting Earth so fast that they keep missing it as they fall. It's like being in an elevator with a cut cable, except the elevator is moving sideways so fast that by the time it would hit the ground has curved away beneath it. This perpetual falling without landing creates the appearance of weightlessness, allowing astronauts to float, but also causing a host of physiological challenges that remind us how deeply our bodies depend on gravity's constant presence. In microgravity, fluids in the body redistribute themselves, no longer pulled downward by gravity. Astronauts' faces become puffy as fluids shift upward and their legs become thinner. Their hearts, no longer working against gravity to pump blood upward, begin to weaken. Bones, without the constant stress of supporting body weight, start to lose density at an alarming rate, up to 1% per month. Muscles atrophy despite rigorous exercise routines. Even the shape of the eyeball changes, causing vision problems that can persist long after returning to Earth. These changes show us that gravity isn't just something we experience. It's something we're built for, something written into the very structure of our bodies over millions of years of evolution. But gravity shapes more than just our bodies. It shapes time itself. This is perhaps Einstein's most mind-bending discovery. Gravity doesn't just bend space, it bends time too. The stronger the gravitational field you're in, the slower time passes for you relative to someone in a weaker gravitational field. This isn't science fiction, it's measurable reality. GPS satellites orbiting Earth have to account for this time dilation, or they would accumulate navigational errors of about 10 kilometers per day. The clocks on those satellites run faster than clocks on Earth's surface by about 45 microseconds per day because they're in a weaker gravitational field. It's a tiny difference, but it's real and it matters. Right now, as you lie there, time is passing slightly slower for your feet than for your head, though the difference is far too small to notice. But near a black hole, where gravity becomes extreme, this time dilation becomes dramatic. Minutes could pass for you while years pass for someone watching from a safe distance. This connection between gravity and time leads us to some of the most profound questions in physics. What exactly is time? Why does it flow in one direction? And how does gravity know how to bend it? These aren't just abstract philosophical questions, they're at the heart of our attempts to understand the universe at its deepest level. The fact that gravity can affect time suggests that time isn't the fixed, absolute backdrop that Newton imagined, but rather something flexible, something that can be stretched and compressed and twisted by the presence of matter and energy. And if time itself is flexible, what does that mean for concepts like causality, free will, and the nature of existence itself? When we look up at the night sky, every point of light we see is held in place by gravity's choreography. The moon orbits Earth orbits the sun orbits the center of the Milky Way, and the Milky Way itself is moving through space, pulled by the gravity of nearby galaxy clusters. It's a cosmic dance that's been going on for billions of years, with each partner following the steps laid out by the curvature of space-time. And remarkably, we can predict these movements with extraordinary precision. We know exactly when the next solar eclipse will occur, down to the second, centuries in advance. We can send spacecraft on decade-long journeys to distant planets, timing their arrival with such accuracy that they can enter orbit using minimal fuel. This predictability of gravity is what makes space exploration possible, turning the solar system into a navigable ocean with invisible currents we've learned to read and follow. The Voyager missions, launched in 1977, used gravity in an ingenious way to tour the outer solar system. Instead of fighting gravity, they used it as a slingshot, stealing a tiny bit of momentum from each planet they passed to boost their speed and change their direction. This technique, called a gravity assist, allowed them to visit Jupiter, Saturn, Uranus, and Neptune using far less fuel than would otherwise have been required. It's like a cosmic game of pinball, with the spacecraft bouncing from one gravitational field to another, gaining energy with each encounter. The Voyager probes are still traveling today, having left the solar system and entered interstellar space, still sending back data as they coast through the darkness, no longer significantly influenced by our sun's gravity, but still feeling the gentle pull of the galaxy itself. When scientists study gravity at cosmic scales, they find something puzzling. Galaxies rotate too fast. Based on the visible matter we can see, stars, gas, dust, galaxies shouldn't hold together at the speeds they're spinning. They should fly apart like a merry-go-round spinning too fast, but they don't, which means there must be something else there, something we can't see that's providing extra gravitational pull. We call this invisible something dark matter, and it appears to make up about 85% of all the matter in the universe. We can see its gravitational effects, the way it bends light from distant galaxies, the way it shapes the cosmic web, but we don't know what it actually is. It's humbling to realize that most of the universe's gravitational pull comes from something we've never directly detected, something that passes through our bodies and our planet continuously without interacting with normal matter except through gravity. And then there's the even stranger discovery that the expansion of the universe is accelerating. When astronomers measured the brightness of distant supernovae in the 1990s, they expected to find that the expansion of the universe was slowing down, held back by the mutual gravitational attraction of all the matter in the cosmos. Instead, they found the opposite. The expansion is speeding up, as if something is pushing space itself apart with ever-increasing force. This mysterious something, which we call dark energy, acts like a kind of anti-gravity on cosmic scales, and it makes up about 68% of the universe's total energy density. So the gravity we know and experience, the force that keeps you in your bed tonight, the force that builds planets and stars and galaxies, represents only a tiny fraction of the forces shaping the cosmos. Most of the universe is dark matter and dark energy, invisible and mysterious, known only by their gravitational effects. But let's return to the gravity you can feel, the familiar force that shapes your daily experience. Every time you take a step, you're momentarily defeating gravity, lifting your body against its pull, then surrendering to it again as your foot comes down. Every time you climb stairs, you're storing gravitational potential energy in your body, energy that could be released if you were to jump back down. Every time you throw a ball, you're creating a parabolic arc, a mathematical curve that Galileo first described and that every projectile follows, from baseballs to ballistic missiles to the water from a garden hose. These everyday interactions with gravity are so common that we rarely think about them, but they're all manifestations of the same force that keeps planets in their orbits and holds galaxies together. Water is particularly interesting in its relationship with gravity. Every river flows downhill following gravity's pull toward the sea. Every raindrop falls from the clouds when it becomes too heavy for air currents to support. Every ocean tide rises and falls in response to the gravitational pull of the moon and sun. The entire water cycle, evaporation, condensation, precipitation, collection, is driven by the interplay of solar energy and gravity. Without gravity, water wouldn't flow, rain wouldn't fall, and the oceans would simply drift away into space as individual molecules. The sound of rain on your roof, the babbling of a brook, the crash of ocean waves, these are all gravity's music, the sound of water following the invisible paths that gravity lays down. Trees have evolved remarkable strategies for dealing with gravity. They must lift water from their roots to their leaves, sometimes hundreds of feet straight up against gravity's pull. They accomplish this through a combination of root pressure, capillary action, and the pulling force of evaporation from leaves, creating continuous columns of water that can defy gravity for the lifetime of the tree. But there are limits. Trees can only grow so tall before the energy cost of lifting water becomes prohibitive. The tallest trees on Earth, the coastal redwoods, max out at around 380 feet, not because they run out of genetic potential for growth, but because they bump up against the physical limits imposed by gravity. Every branch, every leaf, must be strong enough to support its own weight, plus the weight of whatever might land on it, rain, snow, birds, creating an engineering challenge that trees solve with remarkable elegance through their branching patterns and internal structure. Your own body is equally remarkable in its adaptations to gravity. Your skeleton is a masterpiece of engineering, with bones placed and shaped to handle gravitational stress efficiently. Your spine has an S-curve that acts like a spring, absorbing the shock of each step. Your feet have arches that store and release energy as you walk, making locomotion more efficient. Your inner ear contains tiny organs called otoliths, literally ear stones, that sense gravity's direction and help you maintain balance. Your blood vessels have valves that prevent blood from pooling in your legs when you stand. Your lymphatic system relies on muscle movements to pump fluid upward against gravity. Every system in your body has been shaped by millions of years of evolution in Earth's gravitational field, optimized for life at 1G. Now we come to the heart of our journey tonight, the moment where we take everything we know about gravity and very gently, very carefully, turn it inside out like reversing a glove, transforming attraction into repulsion, pull into push, gathering into scattering. This isn't a violent transformation. Imagine instead that reality is shifting as slowly as clouds, change shape on a lazy afternoon, morphing from one form to another so gradually that you can barely perceive the moment of change. You're still lying there safely, still held by normal gravity. But in your mind, we're going to explore what would happen if the fundamental nature of this force reversed itself, if every gravitational interaction in the universe suddenly whispered, "Go away," instead of "come closer." The beauty of a thought experiment like this is that it costs nothing but imagination, requires no equipment but consciousness, and yet it can reveal profound truths about the nature of reality. Einstein himself was a master of thought experiments, imagining riding on beams of light, falling in elevators and standing on accelerating trains, using these mental journeys to discover the deepest laws of physics. Tonight we're following in that tradition, using the power of what if to better understand what is. And the particular what if we're exploring, the reversal of gravity, touches on some of the most fundamental questions in physics and philosophy. Why does gravity only attract? Could it have been different? And what would existence be like in a universe with different rules? Let's begin this transformation slowly, starting with the mathematics. Though don't worry, we won't get lost in equations. In Newton's law of universal gravitation, there's a negative sign that indicates attraction. Two masses pull on each other with a force proportional to their masses and inversely proportional to the square of the distance between them. That negative sign is crucial. It's what makes gravity attractive rather than repulsive. In our thought experiment, we're simply changing that minus to a plus, that negative to a positive, transforming the equation that describes falling apples and orbiting planets into one that describes, well, what exactly? That's what we're here to discover together, slowly and thoughtfully, as we rebuild the universe from the ground up with this one fundamental change. Imagine first that this change happens gradually, perhaps over the course of a few minutes, giving the universe time to adjust. The pull you feel toward Earth begins to weaken, not suddenly but smoothly, like a hand slowly releasing its grip. At first you might not even notice. The sensation would be like the subtle lightness you feel when an elevator begins descending, that brief moment when your weight seems to decrease just slightly. But as the transformation continues, as gravity's pull weakens towards zero and then reverses into a push, you would begin to feel something unprecedented in human experience. The Earth actively trying to repel you, to send you away from its surface. But wait, if gravity is pushing you away from Earth, what's keeping you in place? This is where our thought experiment must become creative, must imagine new forces or mechanisms to prevent the immediate catastrophic dispersal of everything. Perhaps electromagnetic forces become stronger to compensate. Or perhaps there's some new kind of binding force we haven't discovered yet that only manifests when gravity reverses. For the purposes of our gentle exploration tonight, let's imagine that objects can still maintain contact through other means: friction, electromagnetic attraction, chemical bonds, but that these connections must now work against gravity's constant encouragement to separate. Your body, in this pushing universe, would experience every moment differently. The blood in your veins, instead of being pulled downward, would be pushed upward, requiring your heart to work in reverse, pumping hardest to send blood to your feet rather than your brain. Standing up would become easier, the Earth would be helping you rise, but sitting down would require effort, like trying to sink in water that's actively buoying you up. Walking would transform from a controlled fall forward into a controlled rise, with each step needing to push against the Earth's repulsion to maintain contact with the ground. You might need to wear weighted boots or magnetic shoes, something to counteract gravity's constant attempt to launch you skyward. The air around you would behave strangely in this reversed gravity world. Instead of being held down in a blanket around Earth, the atmosphere would try to expand outward into space. We'd need to imagine some kind of containment, perhaps a transparent shell around the planet, or maybe atmospheric molecules that are somehow bound to each other strongly enough to resist gravitational repulsion, while still allowing breathing and weather. The air pressure would be reversed too, highest at the top of this contained atmosphere and lowest at the surface, the opposite of what we experience now. Mountain climbers would find it easier to breathe the higher they climbed, while sea level would become the realm of thin air. Water would refuse to flow downhill because down would no longer be the direction of gravitational attraction. Instead, every droplet would try to move away from Earth's center, creating a tendency for water to flow uphill, to gather at the highest points rather than the lowest. Rain would fall upward, rising from puddles and streams into the sky. Rivers would run from the oceans to the mountains, defying everything we know about erosion and landscape formation. The oceans themselves would be strange, perhaps held in place by massive transparent domes, or by some other force we're imagining to prevent all the water from simply dispersing into space. Waves would break upward, sending spray toward the sky rather than crashing down onto beaches. Plants in this pushing world would need to be reimagined completely. Trees couldn't grow upward against gravity as they do now. Instead, they might grow downward, drilling into the earth to anchor themselves against the constant upward push. Their roots would become what we now think of as branches, spreading through the air to collect moisture and nutrients, while their branches would become roots, holding tight to the soil to prevent the tree from being launched into space. Leaves might be on the bottom, underground, while the photosynthetic surfaces would be the root-like structures in the air. Or perhaps plants wouldn't exist at all as we know them, replaced by entirely different forms of life adapted to repulsive gravity. The formation of planets and stars becomes almost impossible to imagine in a pushing gravity universe, at least through the processes we understand. In our real universe, gravity causes clouds of gas and dust to collapse, heating up as they contract until nuclear fusion ignites and a star is born. But with repulsive gravity, those clouds would expand instead of contracting, cooling as they spread out, never reaching the temperatures and pressures necessary for fusion. Stars simply couldn't form through gravitational collapse, which means the universe would be dark, cold, and diffuse, with matter spreading ever thinner through an expanding void. Unless, of course, there were other forces at play, other mechanisms for concentration and fusion that we haven't imagined yet. Perhaps in this pushing universe, matter would gather in the spaces between gravitational fields, in the null points where repulsive forces balance out. Imagine space filled with invisible hills of gravitational repulsion around every particle, and matter collecting in the valleys between these hills, forming structures not through mutual attraction, but through mutual repulsion that creates pockets of relative stability. These wouldn't be spherical planets or stars, but might be more like sheets or filaments of matter, stretched between repulsive centers, constantly adjusting their shape as the gravitational landscape shifts. The concept of orbits would need to be completely reconsidered. In our pulling gravity universe, orbits are stable paths, where the inward pull of gravity balances the outward tendency of moving objects to travel in straight lines. But with pushing gravity, objects would be repelled away from massive bodies, making traditional orbits impossible. Instead, we might have anti-orbits, where objects are shepherded through space by being pushed away from multiple massive bodies simultaneously, following complex paths through the zones of weakest repulsion. Or perhaps there would be no orbits at all, just a constant dispersal of matter, with everything flying apart forever. Time itself might flow differently in this pushing universe. If gravity pushes rather than pulls, would it still curve space-time? Would massive objects create hills in the fabric of reality rather than valleys? And if so, would time speed up near massive objects instead of slowing down? These questions push at the boundaries of our understanding, where general relativity meets speculation, where mathematics meets imagination. The GPS satellites we talked about earlier would need completely different corrections in a pushing gravity universe, perhaps running slower than Earth clocks instead of faster, or perhaps time dilation would work in ways we can't even predict without working through the transformed equations. Let's think about what would happen to light in this reversed gravity cosmos. In our universe, gravity bends light paths, causing light to curve around massive objects. This gravitational lensing allows us to see galaxies behind other galaxies, creates Einstein rings, and helps us map the distribution of dark matter. In a pushing gravity universe, would light be bent away from massive objects instead? Would we have gravitational diverging lenses instead of converging ones, spreading light apart rather than focusing it? The night sky would look completely different, with starlight being deflected away from any intervening matter, creating dark zones and bright zones in patterns we've never seen. Black holes, those ultimate expressions of gravitational attraction, couldn't exist in a pushing universe, at least not as we understand them. A black hole is a region where gravity is so strong that nothing, not even light, can escape once it passes the event horizon. But if gravity pushed instead of pulled, you couldn't create such a trap. Instead, you might have white holes, regions that nothing can enter because the repulsive gravity pushes everything away. These wouldn't be the white holes that theorists sometimes discuss as time-reverse black holes, but something new, zones of ultimate repulsion, cosmic mountains that nothing can climb. Or perhaps the very concept of such extreme gravitational objects would be meaningless in a pushing universe, with matter never able to concentrate enough to create them. The expansion of our universe, which we currently attribute to dark energy, would be even more dramatic in a pushing gravity cosmos. Not only would space itself be expanding, but every bit of matter would be actively pushing every other bit apart. The universe would fly apart at an ever-increasing rate, with galaxies, stars, planets, and eventually even atoms and subatomic particles being driven away from each other. This wouldn't be the slow heat death that our universe might face billions of years from now, but a rapid dispersal that could happen in mere millions or thousands, or even hundreds of years, depending on how strong the repulsive gravity was. But let's pull back from these cosmic scales and return to the human experience of reversed gravity. Imagine trying to sleep in such a world. Your bed would need to hold you down rather than hold you up, perhaps with gentle restraints or a canopy that keeps you from floating away. The comfort of a heavy blanket would be replaced by something else, perhaps the comfort of a secured sleeping bag that keeps you safely tethered while still allowing movement. Dreams of flying would be replaced by dreams of sinking, of finally being able to rest firmly against something solid instead of constantly being pushed away. Architecture would be revolutionized in a pushing gravity world. Buildings couldn't rely on foundations to transfer their weight into the ground. Instead, they'd need to be anchored against the Earth's attempt to push them skyward. Perhaps buildings would be more like balloons, designed to float at certain heights, tethered by cables to the ground. Or maybe they'd be underground structures, carved into the Earth to resist the upward push. Bridges would arch downward instead of upward, pulled taut by gravity's repulsion rather than sagging under attraction. Every structure would be an exercise in tension rather than compression, holding things down rather than holding things up. Transportation would require complete reimagining. Cars would need to generate downforce to maintain contact with the road, perhaps through magnetic attraction or mechanical gripping. Trains might run on tracks above them rather than below, held up by gravity and guided by rails overhead. Airplanes would find it easier to gain altitude but harder to land, needing to actively push themselves down against gravity's upward thrust. Ships would float not on water but above it, repelled by the ocean's mass, requiring anchors not to prevent drifting but to prevent floating away entirely. Sports and games would transform beyond recognition. A basketball would rise toward the hoop instead of falling toward it, making the game about controlling upward trajectories rather than arcing shots. Swimming pools would need ceilings to contain the water, and swimmers would struggle to dive down while finding it effortless to surface. Ski jumpers would need to focus on staying low rather than flying high. Every sport that depends on gravity, which is nearly all of them, would need new rules, new techniques, new strategies for a world where up is easy and down is hard. Cooking would present unique challenges in a pushing gravity kitchen. Boiling water would see bubbles moving downward instead of upward. Oil and water would separate in reverse, with the denser liquid rising above the lighter one. Baking would require covered pans to prevent cakes from floating out of their containers as they rise. Even something as simple as pouring a cup of coffee would require new techniques, perhaps squeezing liquid from sealed containers rather than relying on gravity to make it flow. The whole art of cuisine would need to be reinvented for a world where nothing wants to stay where you put it. Our emotional metaphors would shift in a pushing gravity world. We wouldn't speak of falling in love, but perhaps of rising in love. Depression wouldn't be described as feeling down, but might be characterized as feeling untethered or dispersed. The weight of responsibility would become the lift of responsibility. Being grounded would mean something entirely different. Perhaps it would mean successfully resisting the constant upward push, maintaining connection despite the forces trying to separate us. Our entire linguistic relationship with up and down, rising and falling, weight and lightness would need to be reconsidered. Music and sound would propagate differently in a pushing gravity atmosphere. With air pressure reversed, sound waves might behave in unexpected ways. Echo patterns would change in spaces where sound waves interact with gravity-defying air currents. Musical instruments that depend on gravity, like piano hammers falling back after striking strings, would need mechanical assistance to reset. The resonance of concert halls would be different with sound waves travelling through air that's constantly trying to expand upward rather than settling in stable layers. Even our understanding of entropy and thermodynamics might shift in a pushing gravity universe. Heat rises in our world partly because hot air is less dense and gravity pulls cooler, denser air beneath it. In a pushing world, would heat sink instead? Would convection currents run in reverse, with cool air rising and warm air descending? This could fundamentally alter weather patterns, ocean currents, and even the way our bodies regulate temperature. The second law of thermodynamics would still hold. Entropy would still increase, but the specific ways that energy disperses might be dramatically different. As we explore deeper into this thought experiment, we begin to see that gravity isn't just one force among many. It's the foundation upon which everything else is built. Every other force and phenomenon in the universe has evolved, in a sense, in the context of attractive gravity. Chemistry assumes that gravity holds reactants together long enough for reactions to occur. Biology assumes that organisms can maintain their structure against gravitational collapse. Even consciousness, perhaps, assumes a universe where things come together rather than fly apart, where complexity can build upon complexity rather than dispersing into ever simpler components. This is the profound realization that emerges from imagining gravity in reverse. We live in a universe perfectly tuned for the emergence of complexity, life, and consciousness, and gravity's attractive nature is a crucial part of that tuning. Change this one fundamental force from pull to push, and everything unravels, not violently but inevitably, like a tapestry whose threads are being gently but persistently pulled apart. The universe we know, the world we experience, the bodies we inhabit, the thoughts we think, all of it depends on gravity working exactly as it does, pulling rather than pushing, attracting rather than repelling, bringing things together rather than driving them apart. And yet, there's something beautiful about imagining the alternative, about mentally inhabiting a universe with different rules, even if just for tonight, even if just in the safety of our imagination. It reminds us that reality could have been different, that the laws of physics aren't logical necessities but contingent facts about our particular cosmos. It makes us appreciate the extraordinary good fortune of living in a universe where gravity pulls, where matter can gather into stars and planets and living beings, where complexity can emerge and persist and evolve, where consciousness can arise to contemplate its own existence, and even imagine how things might have been otherwise. As you continue to rest there, held securely by the familiar pull of Earth's gravity, you can let this pushing universe exist alongside the real one in your mind, not as a replacement, but as a comparison, a contrast that makes the ordinary extraordinary. Every sensation of weight becomes more interesting when you imagine its opposite. Every falling leaf becomes more beautiful when you picture it rising instead. Every stable structure becomes more remarkable when you consider how impossible it would be in a world of repulsive gravity. This is the gift of the thought experiment, not to replace reality, but to refresh our perception of it, to restore wonder to the familiar by imagining the unfamiliar. The transformation we're imagining doesn't have to be complete or consistent or scientifically rigorous. This is a journey of imagination, not a physics exam. You can let the pushing universe be as strange or as familiar as feels comfortable to you right now. Perhaps some things still work normally while others are reversed. Perhaps gravity pushes at some scales but pulls at others. Perhaps it fluctuates between pushing and pulling like a tide, creating cycles of gathering and dispersal. The beauty of imagination is its flexibility, its ability to create worlds that don't need to be perfectly logical, just evocative enough to make us think and feel and wonder. Let us now immerse ourselves fully in this imaginary world where gravity pushes instead of pulls, and let's experience what a single day might feel like for someone who has always lived in such a universe, someone for whom repulsive gravity is as normal and unremarkable as attractive gravity is for you. Imagine waking up not from the weight of your body settling into a mattress, but from the gentle pressure of your sleeping restraints, the soft bands that kept you from drifting away during the night. The morning light filters through your window. Yes, there are still windows in this world, though they might be made of materials we can't imagine, substances that can withstand the constant outward pressure of the atmosphere trying to escape into space. Your first conscious sensation isn't the heaviness of sleep leaving your limbs, but rather a lightness, an upward yearning that never stops. It's not unpleasant. Remember, for someone born in this pushing universe, this would feel as natural as gravity's downward pull feels to you. They wouldn't know anything different. The restraints release automatically as your bedroom senses you're awake, and you float gently upward until your hands find the ceiling grips. Every bedroom has them, these handles and rails that allow you to navigate your morning routine without drifting helplessly around the room. You pull yourself along the ceiling to the bathroom, where everything is designed for a world that pushes rather than pulls. The shower is particularly interesting in this repulsive gravity world. Water doesn't fall from a showerhead above. Instead, it must be actively directed at you from nozzles that fight against its natural tendency to fly upward. The droplets, once they hit your skin, immediately try to float away, creating a constant mist rising toward the ceiling where specialized collectors gather the water for recycling. You don't stand in the shower, you float in a chamber where water jets come from all directions, and the used water is immediately captured before it can disperse. Soap bubbles drift downward instead of upward, sinking through the air like tiny pearls of iridescence. When you're clean, forced air jets dry you quickly, pushing the water droplets into collection vents. Getting dressed requires a different kind of coordination than you're used to. Clothes don't drape naturally over your body. They must be secured, fastened, held in place against the constant upward push. Fabrics are likely designed with this in mind. Perhaps they contain thin magnetic fibers that cling gently to similar fibers in your undergarments. Or maybe they use static attraction, or some other force we haven't discovered yet. Putting on shoes is easier in one sense. You don't have to lift your foot against gravity, but harder in another, as the shoe tries to float away as you attempt to put it on. Everything must be tethered, secured, or held. Nothing can simply be set down and expected to stay. Breakfast in this pushing world is an adventure in contained eating. The kitchen table has a transparent dome over it, keeping food from floating away. You reach through sealed ports to access your meal, which sits on plates with raised edges and subtle magnetic bases that hold them to the table's surface. Pouring cereal is impossible in the traditional sense. The cereal would simply float out of the bowl, so breakfast foods are likely very different. Perhaps they're more paste-like, able to stick to surfaces, or maybe they come in sealed pouches that you squeeze directly into your mouth. Coffee or tea must be drunk from sealed containers with valves, like the water bottles astronauts use, because an open cup would simply let its contents drift away in a brown cloud of dispersing droplets. Your kitchen itself tells the story of adaptation to repulsive gravity. There are no upper cabinets because reaching up is trivial when gravity pushes you that way. Instead, storage is primarily below, in sealed compartments that prevent items from floating out when opened. The refrigerator doesn't rely on convection to circulate cold air. In this world, cold air rises and warm air sinks. The stove, if something like it exists, must account for the fact that heat travels downward, that flames would point toward the floor rather than the ceiling. Perhaps cooking is done in sealed chambers where the behavior of heat and flames can be controlled, or maybe this civilization has developed entirely different methods of food preparation that don't rely on traditional heating methods. Leaving your home to go to work or school requires its own set of preparations. You can't simply walk out the door. You need to ensure you're properly equipped to navigate the outside world. Everyone wears some form of weighted clothing or magnetic shoes, something to maintain contact with the ground. Without them, a strong step could launch you several feet into the air, and without careful control you might drift even higher. Children learning to walk in this world don't fall down when they stumble. They float up, and parents must be ready to pull them back down, to teach them the constant downward pressure needed to maintain contact with the surface. The streets of a city in this pushing gravity world would be marvels of engineering. Sidewalks might have a subtle magnetic quality, or perhaps a textured surface that shoe soles can grip. There would be handrails everywhere, not for support against falling, but for pulling yourself back down when you've bounced too high. Traffic lights would need to be positioned differently, perhaps along the ground where they're easier to see for people who spend half their time looking down to ensure they maintain contact with the surface. Buildings would loom not above but in all directions, some anchored to the ground, others floating at various heights, connected by enclosed bridges and tubes that allow people to move between them without risking drifting away into the sky. Public transportation would be radically different. Buses and trains would need to be enclosed, pressurized vessels, like horizontal elevators moving through tubes or along enclosed tracks. Without enclosure, passengers would simply float out at the first stop. Seats would need restraints, not for safety and crashes, but for keeping passengers in place during normal travel. The vehicles themselves would need to generate significant downforce to maintain contact with their guide rails or tracks, perhaps through magnetic levitation in reverse, magnetic attraction rather than repulsion. The engineering challenges would be immense, but for a civilization that evolved with pushing gravity, these would be solved problems, as natural to them as our wheeled vehicles are to us. The workplace in a pushing gravity world would require constant minor adjustments that would seem bizarre to us but routine to its inhabitants. Office chairs would strap you in, allowing you to work at a desk without drifting away. Computer keyboards would need to be designed for fingers that don't naturally rest on the keys but must actively press down against the upward push. Meetings would take place in enclosed rooms where everyone is gently tethered to their seats, or perhaps floating meetings would be common, with participants drifting slowly around the room as they discuss, using handholds to occasionally adjust their position. Dropping a pen wouldn't mean bending down to pick it up, but rather reaching up to catch it before it floats too high to retrieve easily. Lunch breaks would offer their own unique experiences. Restaurants would be enclosed spaces with controlled environments. Eating soup would be nearly impossible in the traditional sense. Liquids would need to be contained in squeeze pouches or served in containers with lids and straws. Salads would be challenging as lightweight leaves would constantly try to float away. Food culture would likely evolve around heavier, stickier, more cohesive foods that stay together despite the upward push. Fine dining might involve elaborate containment systems, beautiful glass domes, and elegant sealed serving dishes that allow the presentation of food without the risk of it dispersing. The social aspect of sharing a meal would remain, but the mechanics would be entirely different. Children playing in this pushing world would engage in games we can barely imagine. Tag would involve not just running, but controlled bouncing, using the ground as a springboard while trying not to float too high. Playgrounds would have enclosed areas with soft ceilings that children could push off from, bouncing between floor and ceiling in three-dimensional play spaces. Swings would work in reverse, with children pushing against the ground to swing upward, then controlling their descent back down. Ball games would require enclosed courts, with balls that bounce off the ceiling as readily as the floor, creating complex three-dimensional gameplay that would be impossible in our gravity. Schools would teach children from an early age how to manage their movement in 3 dimensions. Physical education would focus not on building strength to jump higher, but on developing control to stay grounded. Students would learn the mathematics of repulsive forces, the physics of dispersion, the chemistry of reactions that occur when substances naturally separate rather than mix. History lessons would tell of the great engineers who first figured out how to contain the atmosphere, the inventors who developed the technologies that allow civilization to exist despite gravity's push. Science classes would conduct experiments that would seem like magic to us, watching objects accelerate upward when released, measuring the rate at which things naturally disperse, studying how plants grow downward into the soil while their roots reach skyward. The natural world in this pushing universe would be alien yet beautiful in its own way. Birds wouldn't fly by generating lift with their wings. Instead, they might use their wings as parachutes or steering surfaces, controlling their inevitable upward drift. They might spend most of their time clinging to surfaces, only flying when they need to move from one anchor point to another. Migration patterns would be vertical rather than horizontal, with birds timing their releases to drift to different altitudes where air currents could carry them to new locations. Nesting would happen in underground burrows or in specially adapted trees that provide downward-facing cavities where eggs won't float away. Trees, as we mentioned earlier, would be inverted by our standards, with what we would call roots extending into the air and branches digging into the soil. But let's imagine them more fully now. These trees would photosynthesize through their aerial roots, which would spread like great green nets in the air, capturing not just sunlight but also moisture and nutrients that drift upward from the soil. Their underground branches would be thick and strong, anchoring the tree against the constant upward push, perhaps even storing energy in dense, heavy formations that help keep the tree grounded. Forests would look like vast green clouds hovering at ground level, with occasional thick trunks disappearing into the earth. Walking through such a forest would mean pushing through hanging root systems, ducking under aerial networks of plant matter, while the solid branches underground would make the soil incredibly difficult to dig through. Weather in this pushing world would be fascinatingly different. Rain would fall upward from bodies of water, rising into the sky where it would collect against the atmospheric barrier we're imagining keeps the air from escaping to space. Clouds would form at ground level as moisture accumulates in the lower, denser atmosphere. Lightning might strike upward from the ground toward the sky, following the path of least resistance through the inverted atmospheric pressure gradient. Storms would be ground-hugging events, with winds that push things upward rather than knocking them down. Tornadoes might be inverted funnels that suck things up from below and disperse them high above. The entire science of meteorology would be reversed, with weather patterns flowing from bottom to top rather than circulating horizontally around the globe. Oceans in this repulsive gravity world present a particular challenge to imagine. Water naturally wants to disperse, to spread out into individual molecules that drift apart. For oceans to exist at all, we need to imagine some containing force, perhaps a biological membrane that evolved to trap water, or maybe electromagnetic fields that hold water molecules together despite gravitational repulsion. These contained oceans would press upward against their barriers, creating inverted pressure gradients where the deepest parts have the least pressure. Marine life would evolve to live in this inverted pressure system, with creatures at the bottom, nearest the surface barrier, adapted for low pressure, while those at the top, nearest the seafloor, would handle higher pressure. Swimming would involve pushing upward against the water's natural tendency to push you down toward the seafloor. Agriculture would require complete reimagining in this pushing world. Farmers couldn't simply plant seeds and wait for rain. They would need to create elaborate systems to keep water and nutrients near their crops' aerial root systems. Greenhouses would be essential, not to keep warmth in, but to keep everything from floating away. Harvesting would involve carefully collecting produce before it detaches and drifts skyward. Soil erosion would work in reverse, with light topsoil constantly trying to float away while heavier minerals sink deeper. Farmers would need to constantly replenish the surface with heavy materials to maintain soil quality. The entire concept of sustainable agriculture would revolve around preventing dispersal rather than managing accumulation. The concept of waste management takes on new dimensions in a pushing gravity world. Garbage doesn't simply fall into bins, it must be actively contained and compressed to prevent it from dispersing. Landfills would be underground chambers where waste is packed upward against containing ceilings. Recycling would be easier in some ways. Materials would naturally separate by density, with lighter materials floating above heavier ones. But collection would be more difficult, requiring enclosed vehicles and careful handling to prevent waste from simply drifting away. The very idea of pollution would be different. Rather than substances settling and accumulating, they would disperse upward, potentially creating layers of contamination at different altitudes. Energy production would face unique challenges and opportunities. Solar panels might be more effective if they could float at optimal heights, held in place by tethers rather than heavy mounting structures. Wind power would work differently with inverted atmospheric dynamics. Wind turbines might need to be oriented horizontally or designed to capture updrafts rather than horizontal winds. Hydroelectric power would be impossible in the traditional sense since water wouldn't flow downhill, but perhaps the constant upward pressure of contained water could be harnessed in other ways. Nuclear power plants would need to account for heat rising downward, requiring cooling systems that work in reverse of what we're familiar with. Communication technology might evolve differently in this world. Radio waves would still propagate, but the ionosphere might be structured differently with an inverted atmosphere, changing how long-distance communication works. Satellite technology would be more challenging. Objects need to be pushed into orbit against gravity's repulsion, rather than lifted against its attraction. Once in orbit, satellites would need constant adjustment to maintain their positions as gravity pushes them away, rather than pulling them in. The whole concept of orbital mechanics would be inverted, with stable orbits being impossible in the traditional sense. Perhaps this civilization would rely more on floating platforms, held at specific altitudes by the balance between gravitational push and atmospheric containment. Art and architecture in this pushing world would reflect the unique physics of their reality. Sculptures would celebrate the tension between form and dispersal, perhaps creating pieces that seem to barely hold together, with elements that strain against each other in delicate balance. Buildings would be designed not just for function, but to express the beauty of contained uplift, with soaring spaces that celebrate the ease of upward movement, while demonstrating mastery over uncontrolled ascent. Fountains would be inverted, with water flowing upward in controlled streams, creating displays that would be impossible in our world. Light installations might play with the way dust and particles naturally rise, creating ascending columns of illuminated moats that dance upward through architectural spaces. Music and performance would adapt to three-dimensional movement. Dancers wouldn't just move across the stage, but through the entire volume of the performance space, pushing off from floors, walls, and ceilings in elaborate aerial choreography. Musical instruments might be designed to be played while floating, with performers tethered at various heights creating vertical orchestras. The acoustics of performance spaces would account for sound propagating through an atmosphere with inverted density gradients, perhaps creating venues where the audience surrounds the performers in 3 dimensions, floating at different levels to experience the music from various angles. Sports would evolve into 3-dimensional competitions we can barely imagine. Basketball might involve goals at multiple heights with players bouncing between floor and ceiling to score. Swimming would be more like flying through water, with athletes pushing against the pool bottom to propel themselves upward through the liquid. Track and field events would focus on control and precision rather than power. The challenge wouldn't be jumping high, but landing accurately. New sports might emerge that are impossible in our world. Three-dimensional racing through enclosed courses, aerial wrestling where opponents try to control each other's movement through space, precision floating where athletes demonstrate control over their position without touching any surface for extended periods. The psychological effects of living in a pushing gravity world would be profound. The constant upward pressure might create a different relationship with effort and rest. In our world, we associate relaxation with sinking, settling, letting gravity take us. In a pushing world, relaxation might be associated with controlled drifting, with the freedom of untethered movement. Anxiety might manifest not as feeling weighted down but as feeling unmoored, too light, unable to maintain connection. The metaphors of mental health would be different. Depression might be described as feeling too heavy to rise, while mania might be unable to touch ground. The fundamental human experience of being grounded, centered, stable would have entirely different physical correlates. Romance and intimacy would require different expressions in a world where bodies naturally push apart. Holding hands would be an active choice requiring constant gentle pressure. Embracing would mean overcoming the natural repulsion between bodies, making physical closeness a more deliberate and perhaps more meaningful act. Dancing would involve partners pushing and pulling against each other's natural drift, creating dynamic movements impossible in our world. Even sleeping beside someone would require intention, with couples perhaps using shared sleeping restraints or interlinked beds that keep them from drifting apart during the night. The elderly and disabled would face different challenges in this pushing world. Age-related muscle weakness wouldn't mean difficulty standing up but difficulty staying down. Mobility aids would be designed to help people maintain ground contact rather than support their weight. Wheelchairs might be more like personal hovercrafts with controls for managing altitude and direction. Physical therapy would focus on developing the strength to resist upward drift, rather than the strength to resist falling. The entire concept of accessibility would be inverted. Ramps would help people descend rather than ascend. Handrails would be for pulling down rather than pulling up. Emergency services would operate under completely different protocols. Firefighters wouldn't worry about people jumping from burning buildings, but about them floating away from safety. Rescue operations would involve catching people who have lost their anchor points, rather than lifting those who have fallen. Ambulances would be sealed vehicles capable of containing patients who might otherwise drift during transport. Medical procedures would require special equipment to keep patients, medications and instruments from floating apart. Even something as simple as applying a bandage would require techniques to overcome the tendency of materials to separate. The legal and social systems of this pushing world would evolve around different fundamental concerns. Property rights might extend vertically in ways we don't consider, with ownership of airspace being as important as land ownership. Laws about maintaining atmospheric containment would be paramount. Any breach that could allow air to escape would be treated as seriously as we treat threats to dam integrity. Social hierarchies might be literally vertical, with status demonstrated by the ability to occupy and control higher altitudes. Prisons would be underground facilities, where the constant upward push serves as an additional barrier to escape. As night falls in this pushing gravity world, the evening routine reverses many of our familiar patterns. Streetlights might shine upward from the ground rather than downward from poles, illuminating the undersides of floating structures and the aerial root systems of trees. People returning home would descend from their workplaces, perhaps riding enclosed elevators that pull them down against gravity's push. Children would be called down for dinner rather than called down from play. The setting sun would create different shadows, with objects casting shadows upward rather than across the ground. Preparing for sleep involves securing yourself for the night. Beds would have gentle restraint systems, perhaps soft nets or cocoons that prevent you from drifting while allowing comfortable movement. Some might prefer to sleep floating, tethered loosely in a room designed for three-dimensional rest. Children might have bedrooms with padded ceilings and walls, allowing them to drift safely during sleep. The comfort of a heavy blanket would be replaced by the comfort of a secure enclosure, something that provides the psychological sense of being held without the physical weight we associate with blankets. Dreams in this world might be different too. Instead of dreams of falling, which tap into our deep gravitational fears, people might dream of uncontrolled ascent, of drifting too far from the ground to return. Flying dreams wouldn't be about defying gravity but about controlling it, maintaining perfect position in three-dimensional space. Nightmares might involve dispersal, dissolution, the loss of cohesion that gravity's reversal threatens. The collective unconscious of this civilization would be shaped by different fundamental anxieties and desires, all stemming from the reversal of the most basic force they experience. Now let us lift our consciousness away from the human scale and drift outward into the vast cosmos of our imaginary pushing gravity universe, where the rules that govern stars, planets, and galaxies are fundamentally inverted, creating a cosmic architecture unlike anything we observe in our pulling gravity reality. Out here, in the tremendous spaces between worlds, the reversal of gravity from attraction to repulsion doesn't just modify the universe we know, it completely reimagines it, creating patterns of matter and energy that challenge our deepest assumptions about how cosmic structures form, evolve, and interact. The night sky in this pushing universe wouldn't be punctuated by points of light gathered into galaxies and clusters. Instead, it might be something far stranger, far more diffuse. A cosmos where matter struggles against its own tendency to disperse into the infinite void. To understand this pushing cosmos, we must first imagine how it might have begun. What kind of Big Bang could birth a universe where gravity repels rather than attracts? In our universe, the Big Bang sent matter flying apart, but gravity immediately began its patient work of pulling things back together, creating tiny variations in density that would eventually become the seeds of all cosmic structure. But in a pushing gravity universe, that initial expansion would be aided rather than resisted by gravity. Every particle would push away from every other particle, accelerating the expansion, preventing any gathering, any clumping, any concentration of matter that could lead to the formation of stars or galaxies. The early universe would be like a perfectly smooth ocean, with no waves, no currents, no features to distinguish one region from another. Unless, of course, there were other forces at play that we haven't yet imagined. Perhaps in this pushing universe, electromagnetic forces are stronger, or perhaps there's an entirely new fundamental force that provides attraction at certain scales, while gravity provides repulsion at others. For tonight's journey, let's imagine that some mechanism exists that can create local concentrations of matter despite gravitational repulsion, perhaps magnetic fields that are billions of times stronger than in our universe, or perhaps quantum effects that become macroscopic at larger scales. Without some organizing principle beyond repulsive gravity, this universe would simply be an ever-expanding cloud of increasingly diffuse particles, a cosmos dying before it could ever truly live. Let's imagine then that in certain regions of this pushing universe, matter has found ways to concentrate despite gravitational repulsion. These wouldn't be stars as we know them, spherical balls of gas held together by their own gravity. Instead, they might be more like cosmic crystals, structures where electromagnetic or nuclear forces create rigid frameworks that resist gravitational dispersal. Picture vast lattices of matter, perhaps millions of miles across, where particles are locked into position by forces other than gravity, creating geometric structures that would be impossible in our universe. These cosmic crystals might glow with their own light, powered by fusion reactions that occur along the edges and vertices where matter is most concentrated, creating patterns of illumination that trace out enormous three-dimensional, geometric forms against the darkness of space. The formation of these structures would be nothing like the gravitational collapse that creates stars in our universe. Instead of gas clouds slowly condensing over millions of years, these cosmic crystals might grow through a process more like crystallization, with particles adding to the structure one at a time when they approach with just the right velocity and orientation to overcome gravitational repulsion and lock into the electromagnetic lattice. It would be a slow, delicate process, easily disrupted by any disturbance, requiring regions of space that are incredibly still and stable. The birth of a new cosmic crystal might take billions of years, with growth rates measured in mere meters per century as the structure slowly accumulates matter against the constant push of gravity. Between these cosmic crystals, space would be different than the space we know. In our universe, gravity creates wells and valleys in space-time, paths that guide matter and energy toward concentrations of mass. But in a pushing universe, massive objects would create hills and peaks in space-time, regions that matter and energy naturally flow away from. The space between cosmic crystals would be crisscrossed with gravitational ridges and valleys, creating a complex topology that would make navigation incredibly challenging. Light itself would follow different paths, bent away from massive objects rather than toward them, creating a cosmic hall of mirrors where the apparent position of objects would rarely match their true location. Orbits, as we understand them, would be impossible in this pushing cosmos. In our universe, orbits are elegant solutions to the balance between gravity's inward pull and an object's tendency to move in a straight line. But when gravity pushes outward, there's no force to curve a moving object's path back toward a massive body. Instead of orbits, we might have what we could call drift patterns, complex trajectories where objects are shepherded through space by the overlapping repulsive fields of multiple massive bodies. An object moving through this pushing cosmos would be like a ball bearing rolling across a landscape of hills, constantly deflected by gravitational repulsion, following the valleys between peaks, but never circling back to where it started. Planets, if they exist at all in this pushing universe, wouldn't orbit stars but might instead be trapped in gravitational nulls, points in space where the repulsive forces from multiple cosmic crystals balance out, creating regions of relative stability. These wouldn't be permanent positions. As the cosmic crystals slowly move through space, pushed apart by their mutual repulsion, the null points would shift, and planets would need to constantly adjust their positions to remain stable. It would be less like orbiting and more like surfing, riding the waves of gravitational repulsion to maintain position relative to energy sources. Some planets might fail to maintain their balance and be expelled into the void, while others might successfully ride the gravitational currents for billions of years. The life cycle of cosmic structures in this pushing universe would be fundamentally different from what we observe in our cosmos. In our universe, stars are born, live and die in cycles that recycle matter and energy, creating new generations of stars enriched with heavy elements. But cosmic crystals in a pushing universe might not die in the same way. Without gravity to trigger collapse when fusion fuel runs out, these structures might simply fade slowly, their lattices gradually breaking apart as the electromagnetic forces that hold them together weaken over time. The matter would then disperse into space, pushed apart by gravitational repulsion, unlikely to ever concentrate again into new structures. It would be a universe of single generations, where each cosmic crystal represents a unique, irreplaceable organization of matter that, once dissolved, is lost forever. The distribution of matter on the larger scales would create patterns we've never seen. Instead of the cosmic web of our universe, with its filaments and voids created by gravitational attraction, a pushing cosmos might display something more like cosmic foam, bubbles of a relatively empty space surrounded by thin shells of matter that has been pushed outward from central points. These shells would be constantly expanding, growing thinner as they spread, occasionally colliding with other expanding shells in events that might trigger brief periods of increased density, and perhaps the formation of new cosmic crystals. The large-scale structure would be dynamic, constantly changing, with no stable configurations that persist for billions of years like the galaxy clusters in our universe. Dark matter, if it exists in this pushing cosmos, would behave completely differently. In our universe, dark matter's gravitational attraction helps hold galaxies together and shapes the cosmic web. But dark matter with repulsive gravity would accelerate the dispersal of visible matter, creating vast zones of avoidance where normal matter cannot penetrate. Perhaps dark matter in this universe would form its own structures, invisible cosmic crystals that push away visible matter, creating clear bubbles in space surrounded by shells of compressed normal matter. The interaction between dark and visible matter would be one of mutual repulsion, creating a segregated universe where the two forms of matter occupy completely different regions of space. Black holes, those ultimate expressions of gravitational attraction in our universe, simply couldn't exist in a pushing cosmos. When a massive star in our universe runs out of fuel, gravity causes it to collapse catastrophically, creating a region where gravity is so strong that nothing can escape. But in a pushing universe, there would be no mechanism for such collapse. Instead, we might have white fountains, regions where matter and energy are constantly expelled outward with tremendous force. These wouldn't be the white holes that some theorists have proposed as time-reversed black holes, but something entirely different. zones of ultimate repulsion where the concentration of matter creates such strong pushing gravity that nothing can approach closer than a certain distance. These white fountains might be the endpoints of cosmic crystal evolution. As a cosmic crystal ages and its electromagnetic lattice weakens, there might come a critical point where the structure suddenly inverts, with all its matter being violently expelled outward by gravitational repulsion. This wouldn't be an explosion in the traditional sense, but more like an uncollapse, with matter accelerating away from a central point, creating expanding shells of high-energy particles that race through space until they dissipate into the cosmic background. The death of a cosmic crystal would be visible across billions of light-years as a slowly expanding sphere of light and matter, a memorial to a structure that once was. The concept of galaxies would need complete reimagining in this pushing universe. Galaxies in our cosmos are vast collections of stars, gas and dust held together by gravity, rotating in elegant spirals or gathering in elliptical clouds. But in a pushing cosmos, such large-scale gravitational binding would be impossible. Instead, we might have what we could call anti-galaxies, regions where matter is actively excluded, creating vast voids surrounded by shells of matter that has been pushed to the periphery. These wouldn't be stable structures, but rather dynamic patterns, constantly evolving as matter is pushed outward and new matter enters from other directions. Within these anti-galaxies, smaller structures might form through non-gravitational means. Perhaps electromagnetic fields could create channels or conduits where matter can flow despite gravitational repulsion, forming rivers of particles that wind through space in complex patterns. These cosmic rivers might be where new cosmic crystals form, in the eddies and calm spots where matter can accumulate despite the overall flow. The anti-galaxy would be like a vast circulatory system, with matter flowing through electromagnetic channels, occasionally pooling into new structures, then eventually being expelled to continue its journey through space. The chemistry of this pushing universe would create different distributions of elements. In our cosmos, heavy elements are forged in the cores of stars where gravity creates the pressure and temperature necessary for fusion. But in cosmic crystals held together by electromagnetic forces, fusion might occur differently, perhaps in thin sheets or along edges where matter is compressed by non-gravitational means. The products of this fusion wouldn't be held within the structure by gravity, but would be immediately expelled, creating streams of heavy elements that flow away from cosmic crystals like rivers of metallic particles. Planets that form in the gravitational nulls between cosmic crystals might be bombarded by these streams, accumulating heavy elements in ways impossible in our universe. Time itself might flow differently in this pushing cosmos. In our universe, gravity slows time, with stronger gravitational fields creating more pronounced time dilation. But if gravity pushes rather than pulls, would time speed up near massive objects? This could create a universe where time flows at dramatically different rates in different regions, with cosmic crystals existing in zones of accelerated time, while the voids between them experience time more slowly. Civilizations near cosmic crystals might age rapidly compared to those in emptier regions of space, creating a cosmos where the rate of evolution and change varies dramatically depending on location. The speed of light might still be the ultimate speed limit, but the paths light takes through this pushing universe would be fundamentally different. Instead of being bent toward massive objects, creating gravitational lenses that magnify distant galaxies, light would be bent away from massive objects, creating gravitational diverging lenses that spread light apart. This would make astronomy incredibly challenging. Distant objects would appear distorted and multiplied, their light scattered by every massive object between them and the observer. The night sky would shimmer with mirages and false images, making it nearly impossible to determine the true position or nature of distant cosmic structures. Communication across interstellar distances would face unique challenges in this pushing cosmos. Radio signals would be deflected by gravitational repulsion, making straight-line communication impossible. Instead, civilizations might need to use gravitational nulls as relay points, bouncing signals through regions where competing repulsive forces create temporary straight paths. Or perhaps they would develop technologies we can't imagine, ways of encoding information in the patterns of gravitational waves created by moving massive objects, using the universe's repulsive gravity as a communication medium rather than an obstacle. The search for life in this pushing universe would require different strategies than what we employ in our cosmos. Instead of looking for planets orbiting stars in stable habitable zones, astronomers would search for objects in gravitational nulls that receive steady energy from multiple cosmic crystals. The signatures of life might be different too. Instead of looking for oxygen atmospheres held by gravity, they might search for contained gas bubbles held by electromagnetic or biological membranes. Life itself might be rarer in this universe, with fewer stable environments where complexity can develop over billions of years. Space exploration in a pushing cosmos would be both easier and harder than in our universe. Launching from a planet would be trivial. Gravity would help push spacecraft away rather than holding them back. But navigation would be incredibly complex, with spacecraft following convoluted paths through the ever-changing landscape of gravitational repulsion. There would be no simple transfer orbits, no gravitational slingshots to gain speed. Instead, space travel might involve riding the expanding shells of matter, from white fountain events, or following the electromagnetic channels between cosmic crystals, or carefully threading through gravitational nulls to reach specific destinations. The ultimate fate of this pushing universe seems clear: eternal expansion and dispersal. Without gravity to pull things together, without the possibility of a big crunch or even a steady state, this cosmos would expand forever, growing colder and emptier as matter spreads ever thinner through an ever larger volume. The cosmic crystals would eventually fade and dissolve, their matter joining the general expansion. The electromagnetic channels would weaken and break. The gravitational nulls would disappear as the massive objects that create them drift too far apart. Eventually, this universe would become a vast, cold, empty void, with particles separated by distances so vast that they might as well exist in separate universes. But perhaps there would be surprises, unexpected emergent properties that arise from repulsive gravity that we haven't imagined. Maybe at extremely large scales, some new force or effect would manifest, creating structures larger than anything we can conceive. Perhaps the universe itself would develop a kind of crystalline structure, with regions of space organizing themselves into patterns that resist dispersal through mechanisms we haven't discovered. The beauty of imagining such a radically different cosmos is that we can't know all its implications, can't predict all the ways that matter and energy might organize themselves under completely different rules. As we contemplate this vast pushing cosmos, with its cosmic crystals and white fountains, its anti-galaxies and gravitational nulls, we're reminded of how precisely balanced our own universe is. The attractive nature of gravity isn't just a minor detail, it's the fundamental organizing principle that makes possible everything from stars and planets to galaxies and the cosmic web. Without gravitational attraction, the universe would be a very different place, perhaps beautiful in its own alien way, but likely unable to support the kind of complex structures that lead to life and consciousness as we know them. Let us now gently return from our imaginary pushing cosmos to examine something remarkable in our own universe, something that suggests our thought experiment might not be entirely fictional after all. As you lie there in the darkness, held securely by Earth's familiar gravitational embrace, I want to tell you about one of the most surprising discoveries in the history of astronomy, a finding that shocked even the scientist who made it and that continues to puzzle cosmologists today. It's the discovery that our universe, the real cosmos you inhabit right now, actually does contain a kind of pushing force, a cosmic repulsion that operates on the largest scales, driving galaxies apart with ever-increasing speed. We call this mysterious force dark energy, and it might be the closest thing in reality to the pushing gravity we've been imagining tonight. The story begins in the 1990s, though its roots reach back much further, to Einstein himself and a mistake he thought he had made. When Einstein first applied his equations of general relativity to the universe as a whole, he found something troubling. The equations suggested that the universe should be either expanding or contracting, not stable and eternal as everyone believed at the time. This bothered Einstein so much that he added an extra term to his equations, something he called the cosmological constant, a kind of anti-gravity that would exactly balance gravitational attraction and keep the universe static. Later, when Edwin Hubble discovered that the universe actually is expanding, Einstein called the cosmological constant his greatest blunder and removed it from his equations. But as we'll see, Einstein's mistake might have been more prescient than he knew. For most of the 20th century, astronomers assumed that the expansion of the universe was slowing down. It made perfect sense. The Big Bang sent everything flying apart. But gravity should be pulling everything back together, gradually slowing the expansion like a ball thrown upward eventually slows, stops, and falls back down. The only question was whether there was enough matter in the universe for gravity to eventually stop the expansion entirely and pull everything back together in a big crunch, or whether the universe would expand forever, just more and more slowly over time. To answer this question, two teams of astronomers in the 1990s set out to measure the expansion rate of the universe at different times in its history. They used a special type of exploding star called a Type Ia supernova as their measuring tool. These supernovae are remarkable because they all explode with nearly the same brightness, making them what astronomers call standard candles. By measuring how bright these explosions appear from Earth, astronomers can calculate how far away they are. And by measuring how much their light has been redshifted by the expansion of the universe, they can determine how fast the universe was expanding when the light left the supernova. It's like having a series of snapshots of the universe's expansion at different times in its history, allowing scientists to piece together how the expansion rate has changed over billions of years. What they expected to find was that the expansion was faster in the past and had been slowing down ever since, pulled back by gravity's patient, persistent attraction. What they actually found sent shockwaves through the physics community. The expansion of the universe isn't slowing down at all, it's speeding up. Galaxies are flying apart faster today than they were billions of years ago, as if some mysterious force is pushing them apart with ever-increasing enthusiasm. It was such a surprising result that both teams spent months checking and rechecking their data, looking for errors, trying to find some mistake that could explain away this impossible observation. But the data was solid. The universe really is accelerating in its expansion. This discovery, which earned the team leaders the Nobel Prize in Physics in 2011, fundamentally changed our understanding of the cosmos. It means that something is counteracting gravity on cosmic scales, something that acts like a kind of anti-gravity or pushing force. Scientists named this something dark energy, not because it's actually dark, but because we don't know what it is. We can see its effects, the accelerating expansion of the universe, but we have no idea what's causing those effects. It's as if we discovered that apples sometimes fall upward, and we can measure exactly how fast they rise, but we have no idea what's pushing them. The Hubble Space Telescope has been instrumental in studying this cosmic acceleration, measuring the brightness of distant supernovae with unprecedented precision. Every observation confirms the same troubling fact. The universe's expansion has been accelerating for about the last 5 billion years. Before that, the expansion was indeed slowing down, just as we expected. But something changed around the time our solar system was forming. Dark energy, which had always been present but overwhelmed by gravity in the early, denser universe, began to dominate as matter spread out and gravity weakened. It's as if the universe has two competing tendencies, gravity trying to pull everything together and dark energy trying to push everything apart, and dark energy is winning. The Planck satellite, launched in 2009, mapped the cosmic microwave background radiation with extraordinary precision, giving us a baby picture of the universe when it was only 380,000 years old. This map confirms that dark energy makes up about 68% of the total energy density of the universe. Think about that for a moment. More than 2/3 of everything that exists is this mysterious pushing force that we don't understand. Dark matter, which we also don't fully understand but at least know attracts gravitationally, makes up another 27%. Normal matter, everything we can see and touch, every star, planet and atom in the universe, makes up less than 5% of what exists. We're truly a small minority in a universe dominated by darkness. The James Webb Space Telescope, our newest eye on the cosmos, is providing even more detailed observations of the early universe, helping us understand when and how dark energy began to dominate cosmic evolution. Its incredible infrared vision can see galaxies that formed when the universe was very young, allowing us to trace the history of cosmic expansion with unprecedented accuracy. Every new observation adds another piece to the puzzle, but so far the picture that's emerging only deepens the mystery. Dark energy appears to be perfectly uniform throughout space and constant throughout time, at least as far as we can measure. It doesn't clump like matter does, doesn't dilute as the universe expands, just maintains its steady push, patient and persistent, driving the cosmos toward an ever more dispersed future. But what exactly is dark energy? This is where our understanding reaches its limits and speculation begins. One possibility is that dark energy is a property of space itself, that empty space has an inherent energy that creates a kind of outward pressure. This would be Einstein's cosmological constant returned from exile, a fundamental feature of space-time that creates a repulsive force. In this view, as the universe expands and creates more space, it also creates more dark energy, which drives further expansion in a never-ending cycle. It's as if space itself wants to grow, to spread, to push everything within it farther apart. Another possibility is that dark energy is a new kind of field, similar to electromagnetic fields, but with very different properties. Scientists call this hypothetical field quintessence, after the fifth element that ancient philosophers thought filled the heavens. Unlike the cosmological constant, quintessence could vary in strength over time and space, potentially creating regions where the pushing force is stronger or weaker. If dark energy is quintessence, then its strength might change as the universe evolves, perhaps growing stronger or weaker in ways we haven't yet detected. Some theories suggest that quintessence could even reverse its effect under certain conditions, switching from repulsion to attraction, though there's no evidence for such behavior. There's even a possibility that dark energy is telling us that our theory of gravity is incomplete, that Einstein's general relativity, as successful as it has been, needs modification on cosmic scales. Perhaps gravity behaves differently when acting over billions of light years than it does in our solar system. Several modified gravity theories have been proposed that could explain the accelerating expansion without invoking dark energy. But so far, none of them match all the observations as well as the dark energy model. It's humbling to think that gravity, the first force that science understood mathematically, might still hold secrets we haven't discovered. The effects of dark energy are only noticeable on truly vast scales. Within our solar system, within our galaxy, even within our local group of galaxies, gravity dominates completely. Dark energy is there, creating its gentle outward pressure, but it's overwhelmed by the much stronger gravitational attraction of nearby matter. It's only in the vast voids between galaxy clusters, where matter is sparse and gravity is weak, that dark energy can show its true strength. This is why we never notice dark energy in our daily lives, why apples still fall down rather than up, why planets still orbit their stars in stable, predictable paths. But on cosmic scales, dark energy is reshaping the universe in profound ways. Galaxies that aren't gravitationally bound to each other are flying apart at ever-increasing speeds. The Andromeda Galaxy, our nearest large neighbour, is still approaching us because we're gravitationally bound in the local group, but most other galaxies are receding, and they're receding faster every year. In about 100 billion years, if the acceleration continues, all galaxies outside our local group will have receded beyond our cosmic horizon, disappearing from view forever. The night sky will gradually empty of all but our nearest neighbours, leaving us apparently alone in an island universe surrounded by unreachable darkness. This cosmic loneliness is part of what scientists call the heat death of the universe, though it might better be called the cold death. As dark energy drives everything apart, the universe will become increasingly cold, dark, and empty. Stars will eventually burn out, black holes will evaporate through Hawking radiation, and matter itself might decay into elementary particles. The universe will reach maximum entropy, a state of perfect disorder where nothing interesting can happen anymore. It's a sobering vision of the future, though one so distant, trillions upon trillions of years away, that it's almost meaningless on human timescales. But perhaps dark energy holds surprises we haven't anticipated. Some theories suggest that dark energy might not be constant but could change over time, potentially even reversing from repulsion to attraction. This could lead to a Big Rip scenario where dark energy becomes so strong that it tears apart galaxies, solar systems, and eventually even atoms themselves. Or it could lead to a cyclic universe where periods of expansion alternate with periods of contraction, with dark energy acting as the switch that triggers each reversal. These are highly speculative ideas, but they remind us how little we really know about the force that dominates our universe. the discovery of dark energy has profound implications for our understanding of physics at the most fundamental level. It suggests that our universe is far stranger than we imagined, dominated by forces we don't understand, heading toward a future we can barely comprehend. It's as if we've been living in a house our entire lives, thinking we knew every room, every corner, every feature, only to discover that the house is actually just a small annex to a vast, mysterious mansion we never knew existed. Dark energy is our first glimpse into that larger structure, a hint that reality extends far beyond what we can see and touch. Interestingly, dark energy provides a real-world connection to our thought experiment about pushing gravity. While dark energy isn't exactly reversed gravity, it doesn't make apples fall upward or planets orbit backward. It does create a kind of cosmic repulsion that drives the largest structures in the universe apart. It's as if our universe is a hybrid of our normal experience and our imagination, with pulling gravity dominating at small scales and pushing dark energy dominating at large scales. We live in the sweet spot where gravity is strong enough to form stars, planets, and life, but the universe as a whole is governed by a force that pushes rather than pulls. Scientists around the world are working on new experiments and observations to better understand dark energy. The Vera Rubin Observatory, currently under construction in Chile, will survey the entire visible sky every few nights, tracking millions of supernovae and mapping the distribution of dark matter and dark energy with unprecedented precision. The Nancy Grace Roman Space Telescope, scheduled for launch in the mid-2020s, will conduct a detailed survey of the infrared sky, measuring the expansion history of the universe in exquisite detail. The European Space Agency's Euclid mission is mapping the geometry of the dark universe, trying to understand how dark energy has shaped the cosmic web. These missions might reveal that dark energy is even stranger than we currently imagine. Perhaps it varies in strength in ways too subtle for our current instruments to detect. Perhaps it's connected to dark matter in ways we haven't discovered. Perhaps it's a window into extra dimensions or parallel universes, or aspects of reality that we haven't even conceived of yet. Every answer in cosmology seems to lead to new questions, each more profound than the last. It's as if the universe is an onion, and every layer we peel back reveals new mysteries underneath. The philosophical implications of dark energy are as profound as the scientific ones. It suggests that the universe is not the clockwork mechanism that Newtonian physics implied, nor even the curved space-time that Einstein described, but something far more dynamic and mysterious. The fact that most of the universe consists of dark energy and dark matter, things we can't see, can't touch, and don't understand, is a powerful reminder of how limited our perception of reality is. We're like fish trying to understand the ocean while being aware of only the tiny fraction of water immediately around us. Dark energy also raises questions about the ultimate fate of life and intelligence in the universe. If the cosmic acceleration continues, the far future will be a cold, empty place where energy sources are exhausted and interesting events become increasingly rare. But perhaps intelligence will find ways to adapt, to harvest energy from the expansion itself, to create pockets of complexity in an increasingly simple universe. Or perhaps the acceleration will reveal new physics, new energy sources, new possibilities we can't currently imagine. The universe has surprised us before, and it will undoubtedly surprise us again. As you lie there tonight, feeling the gentle pull of Earth's gravity, you can also know that you're immersed in dark energy, that mysterious pushing force that fills all of space. It's passing through your body right now, through the Earth, through everything, creating its subtle outward pressure that's too weak to notice at human scales, but strong enough to determine the fate of the cosmos. You are, in a very real sense, living in a universe where gravity both pulls and pushes, where attraction and repulsion are both fundamental features of reality. This duality, pulling gravity and pushing dark energy, might be telling us something deep about the nature of existence. Perhaps every force needs its opposite, every attraction needs a repulsion, every gathering needs a dispersal. Perhaps the universe requires both tendencies to be complete, to be dynamic, to be capable of the rich complexity that leads to stars, planets, life and consciousness. Without gravity's pull, matter would never come together. Without dark energy's push, it might collapse into a single point. The balance between these opposing forces creates the cosmic dance we observe, the eternal tension that keeps the universe interesting. The discovery of dark energy also reminds us to stay humble about our understanding of the universe. Just 25 years ago, we didn't know that most of the cosmos consisted of a mysterious pushing force. What other surprises await us? What other fundamental features of reality are we missing? Perhaps there are other forms of energy we haven't detected, other forces we haven't discovered, other dimensions we haven't accessed. The history of science is full of moments when we thought we had things figured out, only to discover we were missing something essential. Dark energy is the latest reminder that the universe is under no obligation to match our expectations or limit itself to what we can easily understand. Now we venture into perhaps the most mysterious territory of all, where physics meets philosophy, where the reversal of gravity touches not just matter and energy, but the very nature of thought, memory, and consciousness itself. As you rest there in the gentle darkness, your mind creating its own internal universe of thoughts and dreams, let's explore how awareness itself might be different in a cosmos where gravity pushes rather than pulls, where the fundamental tendency is towards separation rather than unity, dispersal rather than gathering. This isn't just about how brains would work differently in a pushing universe, though we'll explore that too, but about how the entire nature of consciousness, memory, and the experience of time might be transformed when the basic force of existence encourages isolation rather than connection. In our pulling gravity universe, consciousness seems to be intimately connected with complexity, with the gathering and organizing of matter into increasingly sophisticated patterns. Your brain, that 3-pound universe of 100 billion neurons, exists only because gravity allowed matter to clump together into stars, which forged heavy elements, which gravity gathered into planets, where chemistry could become biology, and biology could become awareness. Every thought you think, every memory you hold, every dream you dream depends on gravity's patient work of bringing things together. But in a pushing universe, where would consciousness reside? How would awareness emerge from a cosmos that fundamentally prefers dispersal? Perhaps consciousness in a pushing universe wouldn't emerge from matter at all, at least not in the way we understand it. Instead of neurons connected by synapses, creating networks of electrochemical communication, perhaps awareness would arise from patterns in fields, standing waves in the electromagnetic spectrum that maintain coherence despite gravitational repulsion. Imagine beings of pure information, encoded not in the arrangement of atoms but in the relationships between waves, in the interference patterns created when different frequencies interact. These consciousness fields might drift through space, neither pulled together nor pushed apart by gravity because they have no mass, experiencing existence in ways we can barely imagine. Or perhaps consciousness would still emerge from matter, but in forms radically different from our own. In the cosmic crystals we imagined earlier, those vast electromagnetic lattices that resist gravitational dispersal, perhaps awareness could arise from vibrations in the crystal structure itself. Every atom in the lattice would be both a memory storage unit and a processing element, with thoughts propagating as waves through the crystalline matrix. These beings wouldn't have brains in any sense we'd recognize, but their entire physical structure would be their thinking apparatus, every part connected to every other part through electromagnetic bonds that gravity constantly tries to break. The experience of time for conscious beings in a pushing universe might be fundamentally different from our own. We experience time as a flow from past to future, with memories of what was and anticipation of what will be. This experience is shaped by entropy, by the tendency of organized systems to become disorganized, which in our universe is partially counteracted by gravity's organizing influence. But in a pushing universe, where entropy and gravity work together toward dispersal, the arrow of time might feel different. Perhaps beings would experience time not as a flow but as an expansion, with each moment spreading outward from the previous one like ripples on a pond. Memory itself would face unique challenges in a pushing cosmos. In our brains, memories are encoded in the connections between neurons, in the strength of synapses, in patterns that persist because the physical substrate remains stable, held together by electromagnetic forces and ultimately by gravity. But if consciousness existed in field patterns or crystal vibrations in a pushing universe, how would memories persist? Perhaps they would be encoded in standing waves that resist dispersion, or in quantum entanglements that maintain correlation despite physical separation. Memory might not be about storage but about resonance, with past experiences creating frequencies that can be reconstructed when similar patterns arise. The very concept of individual consciousness might be different in a pushing universe. In our world, we experience ourselves as separate beings because our brains are physically distinct, separated by space, and contained within skulls that gravity helps hold together. But if consciousness in a pushing universe existed as field patterns or crystal vibrations, the boundaries between one awareness and another might be less clear. Perhaps consciousness would be more like a spectrum, with regions of greater and lesser awareness that blend into each other without sharp divisions. Individual identity might be a temporary arrangement rather than a fixed feature, with consciousness splitting and merging as field patterns separate and interfere. Let's imagine for a moment what it might feel like to be conscious in a pushing universe. Every thought would be an act of resistance against dispersal, a deliberate gathering of information that goes against the grain of reality. Concentration wouldn't just be a mental effort but a physical one, requiring energy to maintain coherent thought patterns against gravity's encouragement to spread out. Distraction wouldn't be a failure of focus but the natural state, with awareness constantly trying to diffuse into the surrounding space. Meditation might involve not emptying the mind but filling it, creating such dense patterns of thought that they resist gravitational dispersal through their own internal coherence. Dreams in a pushing universe might serve a different function than they do for us. Our dreams seem to be partly about consolidation, about taking the scattered experiences of the day and organizing them into memories, finding patterns and connections. But in a pushing universe, dreams might be about controlled dispersal, allowing consciousness to spread out safely during sleep, exploring the spaces between thoughts without losing coherence entirely. Nightmares might involve uncontrolled dispersal, the feeling of consciousness fragmenting and spreading too thin to maintain identity. Lucid dreams could be about learning to navigate the dispersal, maintaining awareness even as thoughts spread through larger volumes of space. The development of consciousness from birth to maturity would follow a different trajectory in a pushing universe. Instead of the gradual integration and connection of neural networks that characterizes human brain development, perhaps consciousness would begin as a highly concentrated seed that gradually learns to maintain coherence while expanding. Childhood might be about learning to resist dispersal, to keep thoughts together despite gravity's push. Adolescence could involve experimenting with controlled expansion, allowing consciousness to spread out while maintaining core identity. Maturity might be marked by the ability to exist at multiple scales simultaneously, with thoughts that can be both concentrated and dispersed as needed. Language and communication between conscious beings would require different mechanisms in a pushing universe. Sound waves would propagate differently through an atmosphere with inverted density gradients. But more fundamentally, the concept of communication, as sending information from one location to another, might not apply. If consciousness exists as field patterns, communication might be more like interference, with different conscious fields creating new patterns where they overlap. Language might be less about words and more about frequencies, with meaning encoded in the harmonics created when consciousness fields interact. Poetry might involve creating particularly beautiful interference patterns, while arguments could be discordant frequencies that resist harmonization. The relationship between consciousness and physical reality would be different in a pushing universe. In our world, consciousness seems to emerge from matter, organized in particular ways, suggesting that mind arises from body. But in a pushing universe, where matter struggles to stay organized, consciousness might be the organizing principle that allows any complex structures to exist at all. Perhaps consciousness would come first, creating templates or patterns that matter could follow despite gravitational repulsion. Mind wouldn't emerge from matter, but would instead be the force that allows matter to resist its tendency toward dispersal. Emotions in a pushing universe might map to different physical sensations than they do for us. Love, which we often describe as a force that brings people together, might be experienced as a successful resistance to separation, a triumph over the universe's tendency to push things apart. Sadness might not be about feeling heavy, but about feeling dispersed, too spread out, unable to gather one's thoughts. Joy could be the sensation of achieving coherence despite the odds, of thoughts coming together in perfect patterns that resist gravity's push. Fear might be the anticipation of dispersal, the worry that one's consciousness might spread too thin to maintain identity. The collective unconscious, if such a thing exists in a pushing universe, would be shaped by different fundamental anxieties and desires. Instead of Jung's archetypes of falling, drowning, or being consumed, the deep patterns might involve dispersing, dissolving, or losing coherence. The hero's journey might not be about venturing out and returning home, but about maintaining identity, while expanding into new territories of thought. Creation myths might tell of the first consciousness that learned to resist dispersal, gathering enough coherence to observe and understand the spreading universe around it. Artificial consciousness in a pushing universe would face different challenges and opportunities than artificial intelligence in our world. Without stable physical substrates that gravity helps hold together, creating artificial minds might require entirely different approaches. Perhaps artificial consciousness would be easier to create in field patterns than in matter-based substrates. Or perhaps the challenge would be greater, requiring the invention of new forces or fields that can maintain coherence without gravitational assistance. The question of whether an artificial consciousness is truly aware might be easier to answer if consciousness is understood as a pattern rather than an emergent property of complex matter. The philosophical questions raised by consciousness in a pushing universe would be profound. If awareness can exist in field patterns or crystal vibrations, what does that say about the nature of mind? If consciousness must actively resist the universe's tendency toward dispersal, what does that mean for free will and determinism? If individual identity is fluid and temporary, what happens to concepts of responsibility, morality, and meaning? These aren't just abstract philosophical puzzles, but practical questions that any conscious beings in a pushing universe would need to grapple with. Death and continuity of consciousness would have different meanings in a pushing universe. In our world, death often involves the breakdown of physical structures that gravity helped maintain, with consciousness ceasing when the brain stops functioning. But if consciousness in a pushing universe exists as patterns that actively resist dispersal, death might be a gradual process of losing coherence rather than a sudden cessation. Perhaps some aspects of consciousness could persist even as others fade, with memories and thoughts spreading out into space, becoming part of a broader field of awareness that permeates the universe. The possibility of consciousness existing at different scales would be more apparent in a pushing universe. In our cosmos, we tend to think of consciousness as existing at a particular scale, the human scale, roughly. But if consciousness in a pushing universe is about patterns maintaining coherence despite dispersal, those patterns could exist at any scale, where the balance between coherence and dispersal allows. There might be vast consciousnesses the size of solar systems, maintaining thoughts across light years of space, thinking thoughts that take centuries to complete. Or there might be microscopic consciousnesses, tiny patterns of coherence that think a lifetime of thoughts in nanoseconds. The evolution of consciousness in a pushing universe would follow different selection pressures than in our world. Instead of selecting for better integration and more efficient neural processing, evolution might select for better resistance to dispersal, for consciousness patterns that can maintain coherence with less energy expenditure. The history of life might be the history of increasingly sophisticated ways to think coherent thoughts in a universe that encourages incoherent dispersion. Intelligence might be measured not by processing speed or memory capacity, but by the ability to maintain complex thought patterns despite gravitational repulsion. Learning and education would take different forms in a pushing universe. Instead of building neural connections and strengthening synapses, learning might involve developing better techniques for maintaining thought coherence, for resisting the dispersal that gravity encourages. Students might practice concentration exercises that are literally about concentrating their consciousness into denser patterns. Advanced education could involve learning to think at multiple scales simultaneously, maintaining both focused and dispersed thought patterns. Creativity might be about allowing controlled dispersal, letting thoughts spread out in new directions while maintaining enough coherence to bring insights back together. The relationship between consciousness and time might be more fluid in a pushing universe. If conscious patterns can expand and contract, speed up and slow down, then subjective time could vary dramatically even for a single individual. A consciousness might experience centuries of subjective time while physically existing for only moments, or might experience moments stretched across physical centuries. This flexibility of temporal experience could allow for forms of thought and experience impossible in our fixed-time universe. but it could also make communication and coordination between consciousnesses incredibly challenging. Sleep and waking might serve different functions in a pushing universe. Instead of sleep being a time for consolidation and integration, it might be a time for controlled expansion, allowing consciousness to explore larger spaces while maintaining a tether to core identity. Waking might require the effort of pulling consciousness back together, gathering dispersed thoughts into a coherent whole. The cycle of sleep and wake could be like breathing for consciousness, expansion and contraction, dispersal and gathering, a rhythm necessary for mental health in a universe that pulls everything apart. The arts in a pushing universe would explore different themes and use different methods than the arts we know. Music might involve creating interference patterns between consciousness fields, with composers designing frequencies that produce particular emotional or cognitive effects when they interact with listeners' awareness. Visual art might play with the perception of coherence and dispersal, creating works that seem to hold together or fly apart depending on how consciousness focuses on them. Literature might explore the tension between maintaining narrative coherence and allowing stories to branch and spread in multiple directions simultaneously. Meditation and spiritual practices would likely focus on different goals in a pushing universe. Instead of seeking stillness or emptiness, meditation might involve practicing coherence, learning to maintain thought patterns despite the universe's encouragement to disperse. Enlightenment might not be about letting go, but about holding together, achieving a state of consciousness that maintains perfect coherence without effort. Spiritual teachings might emphasize the importance of connection despite separation, of maintaining relationships across the distances that gravity creates. The concept of self would be more fluid and perhaps more precious in a pushing universe. If maintaining a coherent sense of self requires constant effort against gravitational dispersal, then identity becomes an achievement rather than a given. The question, "Who am I?" would have immediate practical importance, as the answer would determine which thoughts and memories to hold on to, and which to allow to disperse. Personal growth might involve not just adding new experiences and knowledge, but actively choosing which aspects of self to maintain, and which to release into the expanding universe. As we contemplate consciousness in this pushing cosmos, we begin to see how deeply our own awareness is shaped by living in a universe where gravity pulls rather than pushes. Every thought you think, every memory you hold, every dream you experience is possible because gravity has created the conditions for complex, stable structures that can support consciousness. The fact that you can maintain a continuous sense of self from moment to moment, day to day, year to year, is a gift of attractive gravity, which holds your brain together and allows the patterns of your consciousness to persist and evolve. Now, as our journey through this imaginary pushing universe begins to near its end, let us turn our attention back toward home, toward the familiar pulling gravity cosmos you inhabit, and see what new appreciation we might have gained from our exploration of its opposite. Sometimes we need to imagine the absence or reversal of something to truly understand its presence and value in our lives, like imagining silence to better appreciate music, or darkness to better value light. Tonight, by imagining gravity reversed, we've been given a gift: the ability to see our own universe with fresh eyes, to recognize the extraordinary in what usually seems ordinary, to feel wonder at the simple fact that things fall down rather than up. Think about the room around you right now, the building that shelters you, the very ground beneath you. All of it exists because gravity pulls rather than pushes. The walls stand because gravity pulls them down onto foundations that push back with equal force, creating stability through opposition. The roof stays on because gravity holds it down, preventing it from flying away into the night sky. Every nail, every screw, every joint in the structure around you assumes and depends upon gravity's downward pull. In our imaginary pushing universe, none of this would work. Buildings would need to be fundamentally reconceived, perhaps as structures that resist upward force rather than downward, or as enclosed spaces that prevent dispersal rather than collapse. The simple fact that you can live in a structure that stays together, without constant maintenance and without active resistance to dispersal, is a gift of attractive gravity. Consider the air you're breathing right now, flowing effortlessly in and out of your lungs. This is only possible because gravity holds our atmosphere in place, creating a blanket of gas around Earth that's dense enough at sea level to sustain life but thin enough at altitude to allow radiation to escape. In a pushing universe, maintaining a breathable atmosphere would require enormous engineering, perhaps a physical barrier to prevent the air from dispersing into space, or perhaps some other force we can't imagine that could contain gas against gravitational repulsion. Every breath you take is a reminder that gravity makes our kind of life possible, creating the conditions where complexity can emerge and persist without constant struggle against dispersal. Water, that most essential substance for life as we know it, behaves the way it does because of gravity. It flows downhill, gathering in rivers and lakes and oceans. It falls as rain, seeps through soil, rises through plant stems against gravity's pull, through the remarkable process of capillary action. The entire hydrological cycle, evaporation, condensation, precipitation, collection, depends on the interplay between solar energy and gravitational attraction. In our pushing universe, water would behave completely differently, perhaps unable to form the large bodies that moderate climate and provide habitat for countless organisms. The fact that you can turn on a tap and water flows out, that you can drink from a glass without the liquid floating away, that rain falls down to water the earth, all of these everyday miracles are gifts of pulling gravity. Your own body is a testament to evolution in a pulling gravity universe. Every aspect of your physiology, from the structure of your bones to the function of your cardiovascular system, has been shaped by billions of years of adaptation to gravitational attraction. Your heart is positioned and powered to pump blood upward against gravity to your brain. Your bones are dense enough to support your weight, but not so dense that movement becomes impossible. Your inner ear contains mechanisms specifically designed to detect gravity's direction and help you maintain balance. In a pushing universe, organisms would need completely different physiological solutions if complex organisms could exist at all. The fact that you can stand, walk, run, and jump, that you can pick things up and put them down, that you can exist as a coherent biological entity. All of this is possible because gravity pulls. The food you eat tells a story of gravitational attraction. Every plant that grows does so by resisting gravity's downward pull while simultaneously depending on it. Seeds fall to the ground where they can germinate. Roots grow downward, following gravity's call while seeking water and nutrients. Fruits hang from branches, held by stems, strong enough to resist gravity until the fruit is ripe and ready to fall. In our pushing universe, agriculture as we know it would be impossible. Plants might grow downward into the soil, fruits might float away before they could be harvested, seeds might disperse into the sky, never to return. The entire chain of life that feeds you exists because gravity creates stable conditions where energy and nutrients can cycle through ecosystems rather than dispersing into space. The warmth you feel, whether from sunlight from a heater or from your own body heat, behaves predictably because of gravity. Hot air rises in our world because it's less dense than cool air, and gravity pulls more strongly on denser substances. This creates convection currents that distribute heat, moderate temperatures, and drive weather patterns. In a pushing universe, heat distribution would work differently, perhaps with hot air sinking and cool air rising, creating entirely different patterns of energy flow. The comfort of a warm blanket, the coziness of a heated room, the pleasure of sunlight on your skin, all of these experiences are shaped by how gravity organizes matter and energy in our universe. Relationships and communities exist as they do because gravity creates the conditions for beings to come together and stay together. In our world, people naturally gather, creating families, communities, cities, civilizations. While social and emotional forces drive these gatherings, they're only possible because gravity provides a stable platform where beings can meet, interact, and build together. In a pushing universe, where the fundamental force encourages separation, would conscious beings still seek connection? Perhaps they would, working against the cosmic tendency toward isolation, making every relationship a deliberate choice to resist the universe's dispersing influence. The fact that you can sit with loved ones, share meals, embrace without floating apart, these are gifts of attractive gravity that we rarely appreciate. The passage of time as you experience it is shaped by living in a pulling gravity universe. Your days and nights exist because gravity holds Earth in orbit around the Sun while the planet rotates on its axis. Your years mark Earth's gravitational dance around our star. The seasons change because Earth's axis is tilted relative to its orbital plane, causing different amounts of sunlight to reach different parts of the planet throughout the year. In a pushing universe without stable orbits, would there be days and nights? Would there be seasons? The regular rhythms that structure your life, from daily routines to annual celebrations, all depend on gravitational relationships that wouldn't exist if gravity pushed instead of pulled. Art and beauty in our world often celebrate forms and patterns that gravity makes possible. The graceful arc of a fountain, the elegant curve of a bridge, the way fabric drapes on a body, all of these aesthetic experiences assume and depend on gravitational attraction. Dancers leap and land, creating beauty through their negotiation with gravity. Sculptures balance and cantilever, playing with gravity's pull to create visual tension and interest. In a pushing universe, beauty would need to be found in different forms, perhaps in patterns of controlled dispersal, or in structures that successfully resist separation. Our aesthetic sense has been shaped by millions of years of evolution in a pulling gravity world, teaching us to find beauty in forms that work with or artfully resist gravitational attraction. The night sky you see, with its stars and planets and occasional meteors, exists because gravity pulls matter together into discrete objects that shine or reflect light. In our pushing universe, the night sky might be a diffuse glow with no point sources, or perhaps it would be completely dark if matter couldn't concentrate enough to form stars. The constellations that humans have used for navigation and storytelling for millennia wouldn't exist. The moon that lights some nights and creates our tides would never have formed. The fact that you can look up and see distinct points of light, that you can identify planets and stars, that you can witness meteor showers and eclipses, all of these wonders are gifts of attractive gravity. Science itself, the systematic study of nature that has revealed so much about our universe, depends on the stability and predictability that gravity provides. We can conduct experiments because objects behave consistently in gravity's field. We can build instruments because materials hold together reliably. We can make observations because light travels in predictable paths, bent by gravity in ways we can calculate and account for. In a pushing universe, would science as we know it even be possible? Perhaps beings would develop different ways of understanding their cosmos, ways suited to a reality where dispersal rather than gathering is the norm. The scientific knowledge that enriches your understanding of the world is built on a foundation of gravitational stability. Technology, from the simplest tools to the most complex machines, assumes and exploits gravitational attraction. A hammer works because gravity accelerates it downward when you swing. A wheel rolls because gravity presses it against the ground, creating friction. Bridges stand because gravity compresses their materials in predictable ways. Even our most advanced technologies, like computer chips and smartphones, depend on manufacturing processes that assume gravitational conditions. In a pushing universe, technology would need to be completely reimagined, perhaps based on principles of controlled dispersal rather than controlled gathering. Every device you use, every tool that makes your life easier, is designed for and depends upon a universe where gravity pulls. Medicine and healing in our world work with bodies shaped by gravitational evolution. Doctors understand how blood pools in lower extremities, how bones bear weight, how organs are positioned and supported by gravitational forces. Treatments from surgery to physical therapy assume and work with gravitational effects. In a pushing universe, if biological organisms existed at all, medicine would be a completely different discipline, dealing with bodies that face opposite gravitational challenges. The medical knowledge that keeps you healthy, the treatments that heal injuries and cure diseases all assume and depend upon the gravitational conditions of our universe. Memory and history accumulate in our world because gravity creates stable conditions where information can be preserved. Books stay on shelves, monuments stand for centuries, artifacts remain where they're buried until archaeologists uncover them. In a pushing universe, preserving information would be a constant struggle against dispersal. Would civilizations develop different methods of maintaining cultural memory? Perhaps they would encode information in field patterns that resist gravitational spreading, or perhaps they would accept that all information is temporary, developing philosophies that embrace rather than resist the loss of history. The fact that you can learn from the past, that libraries and museums exist, that we can build on the knowledge of previous generations, all of this depends on gravitational stability. Love and connection in our world are often described in gravitational terms. We fall in love, we're attracted to others, we feel pulled toward those we care about. These metaphors aren't arbitrary. They reflect a deep alignment between our emotional experiences and the fundamental force that shapes our physical reality. In a pushing universe, would beings still seek connection despite cosmic encouragement toward separation? Perhaps love would be even more precious, representing a choice to resist universal tendencies. Or perhaps consciousness would evolve different forms of connection that don't require physical proximity. The relationships that give your life meaning exist in their current form because you live in a universe where coming together is physically natural. Purpose and meaning in our lives often involve building, creating, and connecting, all activities that work with gravitational attraction. We build homes, create art, form communities, leave legacies. In a pushing universe, would purpose be found in different activities? Perhaps meaning would come from successfully resisting dispersal, from maintaining coherence despite cosmic opposition. Or perhaps beings would find purpose in controlled, beautiful forms of separation, in artistic dispersal that creates new patterns as things spread apart. The goals and dreams that motivate you are shaped by living in a universe where building up is possible, where things can come together and stay together long enough to matter. Death in our world is often understood as a return to the earth, a rejoining with the matter from which we came. Dust to dust, we say, acknowledging that gravity will eventually reclaim our bodies, breaking them down and recycling their elements into new forms. In a pushing universe, death might mean dispersal into space, a spreading so thin that coherence is lost forever. Would this make death more or less frightening? Would beings develop different philosophies about mortality, perhaps seeing death as a liberation from the constant effort of maintaining coherence? The way you understand and relate to mortality is shaped by living in a universe where gravity ensures that nothing is ever truly lost, only transformed and recycled. Hope in our world often involves the belief that things can come together, that problems can be solved, that connections can be made or renewed. This hope is physically grounded in a universe where gathering is possible, where dispersed things can reunite. In a pushing universe, hope might take different forms. Perhaps the hope that important patterns can be maintained despite dispersal, or that new forms of organization can emerge that work with rather than against gravitational repulsion. The optimism that helps you face each day is supported by living in a universe where building, healing, and connecting are physically possible. Wonder and curiosity, those driving forces of human experience, are nourished by living in a universe with enough stability to reward investigation, but enough mystery to keep us searching. If gravity pushed instead of pulled, would conscious beings still wonder about their cosmos? Perhaps they would, but their questions would be different. Not, how do things come together? But how can we prevent things from flying apart? Not, what holds the universe together? But what allows anything to maintain coherence? The questions that fascinate you, the mysteries that draw your curiosity, are shaped by the particular physics of our pulling gravity universe. Gratitude takes on new dimensions when we truly appreciate what gravitational attraction makes possible. Every stable moment, every lasting connection, every accumulated achievement exists because gravity pulls rather than pushes. The cup of tea that stays in its cup, the pet that sleeps beside you, the photograph that preserves a memory, the song that travels through air to reach your ears. Countless experiences that enrich your life depend on gravitational attraction. By imagining its opposite, we can cultivate deeper appreciation for the force that quietly, constantly makes our existence possible. As you lie there in the darkness, feeling gravity's familiar pull, you can now experience it not as a limitation but as a gift. It's not holding you down, it's holding you together, keeping you connected to the earth, to other beings, to the cosmos itself. Every sensation of weight is a reminder that you exist in a universe where things can come together and stay together, where complexity can emerge and persist, where consciousness can arise to contemplate its own existence. The thought experiment of reversed gravity hasn't taken you away from reality, but has brought you closer to it, helping you see the extraordinary in the ordinary, the miraculous in the mundane. And now, as our long journey through the night nears its end, we begin the gentle return from our imaginary pushing cosmos back to the familiar world of pulling gravity that cradles you right now. like a deep sea diver slowly ascending to avoid the bends, or like a dreamer gradually waking while trying to hold on to the feeling of the dream, we'll ease back into normal reality, while keeping with us the insights and wonder our thought experiment has provided. The pushing universe we've explored tonight isn't going to suddenly vanish. It will remain in your imagination, a parallel possibility that makes the actual universe more interesting by comparison, a shadow world that gives depth and dimension to the world you inhabit. Feel yourself there in your bed, on your couch, in your chair, wherever you're resting as you listen to these words. Feel the weight of your body, that gentle, constant pressure that tells you gravity is doing its patient work of holding you to the earth. But now, after our journey, perhaps that sensation feels different. It's not just weight anymore, it's connection, it's belonging, it's your matter in conversation with Earth's matter, mediated by the curved space-time between you. Every molecule in your body is participating in this gravitational relationship, each one contributing its tiny voice to the chorus that creates your weight. You're not just on the Earth, you're with the Earth, held in an embrace that has lasted your entire life, and will continue until your atoms are recycled into new forms. The room around you, which might have seemed ordinary when we began this journey, now reveals itself as extraordinary. The air isn't just empty space, but a carefully balanced atmosphere held in place by gravity's grip, dense enough at this altitude to fill your lungs with life-giving oxygen. The walls aren't just barriers, but triumphs of engineering that work with gravity to create shelter. The floor beneath you isn't just a surface, but a platform in space, the top layer of a planet that gravity has shaped into a sphere, floating in a cosmic void but feeling absolutely solid and reliable, because gravitational attraction makes it so. As you breathe slowly and deeply, you can appreciate that each breath is only possible because we live in a pulling gravity universe. The air flows into your lungs because atmospheric pressure, created by gravity's compression of the atmosphere, pushes it in when your diaphragm creates a lower pressure space. The oxygen molecules bind to your red blood cells and travel through your body, pumped by a heart that evolution has positioned and powered to work against gravity's downward pull. Every cell in your body receives the oxygen it needs because your cardiovascular system has evolved over millions of years to function in Earth's gravitational field. In our imaginary pushing universe, none of this would work the same way, if it could work at all. The question we began with, what if gravity pushed instead of pulled, has taken us on a journey through physics, cosmology, biology, philosophy, and consciousness itself. We've seen how changing this one fundamental force would ripple through every aspect of existence, transforming not just how things fall, but how stars form, how time flows, how consciousness might emerge and experience reality. And through imagining this radical alternative, we've gained a deeper appreciation for the universe we actually inhabit, recognizing how precisely tuned it is for the emergence of complexity, life, and awareness. But the mystery doesn't end with our return to pulling gravity. In fact, it deepens. Why does gravity pull rather than push? This isn't a question science can currently answer. We can describe how gravity works with extraordinary mathematical precision. We can predict its effects across billions of light years and billions of years, but we don't know why it's attractive rather than repulsive. It could have been different. The equations of general relativity work just as well, with a positive cosmological constant, dark energy, as with traditional attractive gravity. The fact that gravity pulls at the scales of planets and stars while dark energy pushes at cosmic scales suggests that the universe is more complex and mysterious than either pure attraction or pure repulsion would be. Perhaps gravity pulls because that's the only way a universe can evolve to the point where conscious beings can ask why gravity pulls. This is the anthropic principle, the idea that we observe the universe to have the properties it does, because if it had different properties, we wouldn't be here to observe it. If gravity pushed instead of pulled, stars wouldn't form, heavy elements wouldn't be forged, planets wouldn't orbit stars, chemistry wouldn't lead to biology, and consciousness wouldn't emerge to wonder about gravity. We live in a pulling gravity universe because pulling gravity universes are the only kind that can support observers like us. But maybe, somewhere in the vast multiverse that some theories propose, there are universes where gravity does push instead of pull. Perhaps there are cosmos where different forces or mechanisms allow complexity to emerge despite repulsive gravity. Maybe consciousness has found ways to exist that we can't imagine, creating forms of awareness that thrive on dispersal rather than gathering. These universes would be forever separated from ours, unreachable across the void between realities, but their possible existence adds another layer to the mystery. We're not just asking why our universe has pulling gravity, but whether pulling gravity is necessary for any universe with observers. The discovery of dark energy that we discussed earlier adds yet another dimension to this mystery. We live in a universe that seems to have both pulling and pushing tendencies, with gravity dominating at small scales and dark energy dominating at large scales. It's as if the cosmos is engaged in a constant negotiation between gathering and dispersing, between coming together and flying apart. This tension creates a dynamic universe that's neither collapsing into a single point nor dispersing into absolute emptiness, but maintaining a delicate balance that allows for the emergence and evolution of complex structures. As you continue to rest there, you're experiencing this cosmic balance directly. Gravity is holding you to Earth, but dark energy is slowly pushing Earth's galaxy away from other galaxies. You exist at the scale where gravity wins, where matter can gather and stay together long enough for interesting things to happen, but you're also embedded in a larger reality where dark energy is gradually taking control, ensuring that the universe will expand forever, growing colder and emptier over cosmic time. You're living in a special epoch when both forces are relevant, when the universe is neither too dense nor too diffuse, neither too hot nor too cold, neither too young nor too old for consciousness to emerge and thrive. This thought experiment we've conducted tonight, imagining gravity reversed, is part of a long tradition of using imagination to understand reality. Scientists and philosophers have always asked what if questions to illuminate what is. What if the speed of light were different? What if there were more or fewer dimensions? What if time could flow backward? What if parallel universes exist? These questions aren't idle speculation, but powerful tools for understanding the nature of existence. By imagining alternatives, we see more clearly the specific features of our reality and appreciate how remarkable it is that things are the way they are. Your imagination itself is one of the most remarkable products of our pulling gravity universe. The fact that you can conceive of gravity working differently, that you can mentally construct and explore an alternative cosmos, is a testament to the power of consciousness that emerged from billions of years of gravitational gathering. Your brain, with its 100 billion neurons and trillion synapses, is one of the most complex structures in the known universe, and it exists only because gravity allowed matter to concentrate into stars and planets where evolution could work its patient magic. The thoughts you're thinking right now are made possible by gravity's pull. But consciousness doesn't just passively benefit from gravity, it actively works with and against it. Every time you stand up, you're defying gravity. Every time you throw a ball or jump or climb stairs, you're negotiating with gravity, using energy to temporarily overcome its pull. Humans have even learned to escape Earth's gravity entirely, sending spacecraft to other planets and beyond. We've turned gravity from a limitation into a tool, using gravitational slingshots to explore the solar system, using our understanding of curved space-time to navigate the cosmos. Consciousness has evolved to the point where it can understand and manipulate the very force that made its existence possible. The future of our pulling gravity universe remains mysterious and full of possibility. Will dark energy continue to accelerate cosmic expansion forever, leading to a cold, empty universe trillions of years from now? Will it change in strength, perhaps even reversing to allow gravity to pull everything back together? Will we discover new physics that unifies gravity with the other fundamental forces, revealing deeper patterns we haven't imagined? Will consciousness find ways to survive and thrive even as the universe expands and cools, perhaps by creating new baby universes or by transcending physical reality altogether? These questions remind us that our journey of understanding has just begun. As this night's exploration draws to a close, you can carry with you a renewed sense of wonder about gravity, that most familiar of forces. It's not just something that makes things fall or keeps planets in orbit. It's the cosmic sculptor that shapes everything from atoms to galaxies, the patient force that enables complexity to emerge from simplicity, the invisible thread that connects every piece of matter to every other piece across the vastness of space. Without gravity's pull, there would be no stars to forge elements, no planets to serve as platforms for life, no stable structures where evolution can experiment with increasing complexity. The pushing universe we imagine tonight will fade back into imagination, but it leaves behind a gift: the ability to see our pulling universe as the remarkable, improbable, precisely tuned reality it is. Every moment of stability in a universe trending toward entropy, every connection in a cosmos expanding toward isolation, every thought in a reality that could have been thoughtless. All of these are precious because they're not inevitable. They exist because gravity pulls rather than pushes, because the constants of nature have exactly the values they do, because the universe somehow allows for the emergence of beings who can contemplate their own existence. You began this journey with a simple question: what if gravity pushed instead of pulled? Now you've seen how that single change would transform everything, from the largest cosmic structures to the smallest quantum interactions, from the formation of stars to the nature of consciousness itself. And in seeing how different things could be, you've gained a deeper appreciation for how things actually are. The weight you feel right now isn't a burden, but a blessing, a constant reminder that you live in a universe where things can come together, where connections are possible, where complexity can emerge and persist. Tomorrow, when you wake and stand up feeling gravity's familiar pull as your feet touch the floor, perhaps you'll experience it differently. When you pour your morning coffee and watch the liquid flow down into your cup, when you see birds flying against gravity's pull, when you feel the sun's warmth carried to you across 93 million miles of space because gravity keeps Earth in orbit at just the right distance, all of these ordinary experiences can become extraordinary when you remember they depend on gravity pulling rather than pushing. The mystery we've explored tonight doesn't have a solution, and that's part of its beauty. We don't know why gravity pulls, why the universe has the exact properties it does, why consciousness emerged from matter, why anything exists at all. But we can appreciate the mystery, explore it with our imagination, probe it with our science, contemplate it with our philosophy. The fact that we can ask these questions, that we can imagine alternatives, that we can wonder about the nature of existence, this itself is the greatest mystery and the greatest gift of our pulling gravity universe. As you drift towards sleep, you can release the imaginary pushing universe we've constructed tonight, letting it dissolve back into the realm of possibility from which it came, but keep with you the wonder it has awakened, the appreciation it has fostered, the questions it has raised. You're returning to the familiar world of pulling gravity, but you're returning with new eyes, able to see the miraculous in the mundane, the extraordinary in the everyday, the mystery in the familiar. Feel yourself held by gravity's patient embrace, not trapped, but cradled, not limited, but enabled. Every atom in your body is connected to every atom in the universe through gravity's infinite reach. You're part of a cosmic web of relationships that stretches across space and time, linking you to stars being born in distant galaxies and to particles at the edge of the observable universe. This connection isn't metaphorical but physical, measurable, real. Gravity makes you part of something larger while allowing you to be distinctly yourself. The Earth turns beneath you, carrying you through space at thousands of miles per hour, held in orbit by the sun's gravity. The sun itself moves through the galaxy, carried by gravitational currents we're only beginning to map. The galaxy dances with other galaxies in a cosmic ballet choreographed by gravity and dark energy. And through it all you rest safely in your bed, feeling only the gentle, constant pull that tells you you're home, you're connected, you're part of this vast, mysterious, beautiful universe where gravity pulls rather than pushes. Sleep is approaching now, that daily surrender to gravity where you release conscious control and let your body rest fully against the Earth's pull. In your dreams tonight, you might find echoes of our journey. Perhaps you'll dream of floating, of things falling upward, of the strange beauty of a universe with different rules. Or perhaps you'll dream of this world, seeing it fresh and new, appreciating its familiar wonders as if encountering them for the first time. Either way, you'll wake tomorrow in a universe where gravity pulls, where things fall down, where matter gathers into stars and planets, and living beings who can wonder about it all. The cosmic questions we've explored tonight don't have answers, at least not yet, and perhaps they never will. But that's not a cause for frustration. It's a source of wonder. We live in a universe that's comprehensible enough that we can study it, but mysterious enough that we'll never run out of questions. We understand enough to appreciate how special our cosmic situation is, but not so much that the magic is gone. We know that gravity pulls, but we don't know why. We know that dark energy pushes, but we don't know what it is. We know that consciousness emerged from matter organized by gravity, but we don't know how or why or what it really means. And so, our journey through the pushing universe comes to an end, not with answers, but with deeper appreciation, not with certainty, but with wonder, not with closure, but with opening to the continuing mystery of existence. You've travelled far tonight without moving at all, exploring an alternative cosmos from the safety of your bed, using imagination as a vehicle for understanding, and now you return, enriched by the journey, carrying with you new ways of seeing the familiar world. Gravity continues its patient work as you drift towards sleep. It holds the blanket against your body, keeps the air you breathe from dispersing into space, maintains the conditions that make your existence possible. It's been doing this work for billions of years, gathering matter into stars, forging elements in stellar cores, building planets where life can emerge, creating the conditions for consciousness to arise and wonder about itself. And it will continue this work long after you sleep, long after you wake, long after all of us are gone, patient and persistent, the force that brings things together in a universe that's flying apart. Rest now in gravity's embrace, in the pull that makes all things possible, in the mysterious attractive force that somehow led to you lying here, capable of imagining it all differently. The pushing universe fades into imagination, but the pulling universe remains solid and reliable and full of wonder, waiting for you when you wake, ready to support another day of existence in this remarkable cosmos where things fall down, where matter gathers, where consciousness can emerge to contemplate the mystery of it all. What if gravity pushed instead of pulled? Now you know, everything would be different, and knowing that, you can never again take for granted the simple, profound, beautiful fact that in our universe, gravity pulls. Sweet dreams in this pulling gravity cosmos, where you're held safe through the night, where the earth spins steadily beneath you, where stars shine in the darkness, where tomorrow will come as surely as gravity continues its ancient work. The mystery remains, will always remain, but that's what makes existence interesting, what makes consciousness worthwhile, what makes each moment of awareness a gift in a universe that could have been otherwise but somehow, mysteriously, beautifully, is exactly as it is.